Hello everyone, my name is Shambhavi. Hope you all are doing well. Welcome to this new course of Numpy Library for Data Science. So basically in this course we are going to cover that what is Numpy Library. We are going to see the differences between the list and Numpy because list and array. Actually they both look the same, right? So we are just going to see the difference. After that we'll be moving one by one towards all the functions of NumPy arrays, and we'll be seeing all of the functions acting upon some array, some n dimensions array, and we have lot of stuff to do in this course, right? So in this video let me start up with the uh, numpy, that what is actually the numpy library, what it is used for, how to install that onto our devices, right? So let's begin up here. So first of all, let me just quickly write out the name for the library that we are going to discuss today, and that one is here, which is numpy library. So I would just recommend all of you to make your own notes, okay? That will be very beneficial for you to revise at the whenever you just want to go to somewhere, some interview somewhere like this, it will be very beneficial for you to revise up the things. So basically NumPy is one of the libraries which is essentially used for, like it is especially used for doing the mathematical calculations. So whenever we just talk about doing about the mathematical like calculations using some libraries of Python or data science, the first thing comes about the NumPy library. So it is a type of library which actually deals with the arrays. Most of the functions which are on the NumPy library, they are performed on the arrays. Okay, so we all know arrays 1D, 2D. We'll be discussing about this in a like detail in the upcoming videos. But right now, just understand this thing that NumPy is a library which actually like especially deals with the numbers. Okay, we have the functions which are actually dealing with the numbers here, right? So it is a library which is used for especially the mathematical calculations, right? This is the very basic thing about the NumPy library. Other than that, the thing comes at how to use this library, right? So for using this library, I would be telling you two ways, either the online or the offline ones. Okay, I would be telling you that basically if you just want to use it on online, so how you can, and if you just want to use it on offline, so how you can. So let me just quickly move on to one of my PyCharm IDEs which I'll be using for this whole course. Okay, so this is the PyCharm IDE that I would be using. Okay, you can just use any IDE which you basically you are referring from the previous. Right now I'm just using this PyCharm. Okay, so I had made one file here. Let's see this one. Now let's say I just want to use NumPy. So for using out the NumPy, the very first step that we need to follow is that we need to install that library onto our devices. Before, like if you're just using online, and in that basically do not need to install. But if you are using an offline IDE, in that case basically you need to install this library. Okay, so before, like if you are not installing it, it would not work for you. Okay, so I'm just telling you the way for doing it on this PyCharm. Okay, just go on to here. 5 options will be coming downside, that are git, to do, terminal, Python console, and problem. So just click on the terminal, right? So this is a terminal basically where we just install the libraries in the PyCharm IDE. Okay, now the command for installing any of the libraries, I'm just not simply talking about any single library, let's say NumPy or any library. I'm just telling you the normal command which is used for any of the libraries which you want to install. Okay, so that is basically pip install install. Okay, so pip install is the basic command which is used for installing any library. Let's say let's take NumPy, pandas, cbon, matplotlib, any library which you want to install on the offline ones. Okay, so pip install, and after this you need to write out the library name, and let's say for us it is NumPy, and just hit enter. So it will basically install onto your PyCharm IDE, and after that it is installed, it will be ready to use this library. So for me the requirement is already satisfied because I have already installed it onto my device. But if you haven't done it till now, so for it will be showing that initializing, installing, and after that it's like sometime it will show successfully installed. Actually this depends on your internet connection, that how much bandwidth you are having, right? It depends on that thing. Fine, this is that how you just install it on the PyCharm IDE. Now, let's say you are having any other IDE and you are not able to understand how to install that. So, in that case, basically, you can just simply open the command prompt. Okay, just click on this command prompt here. You can just simply open it, and here you can just install out the library which we are just gonna use. That one is, the command would absolutely remain the same, that is pip install, and here it is NumPy, and hit enter. So it will basically install it from here for you. Okay, if you are not able to install it from the PyCharm or any other whichever you are using, fine. Okay, and I will just close it here. So for the online, you do not need to install. So that is the other case as well, right? You do not no need to install it for the online ones. Fine. Now this is about the NumPy library, that why it is used and how it is used. Now basically, like many of you must be having one question in your mind, that why we just use the arrays. See, what's the thing in array? Okay, like how we just declare an array. So array is declared basically in the large brackets, right? We just put a number of numbers, whatever we just have, and we just declare it like this. Other than this, if you have a good command over Python, and there basically you have studied about the list. Lists are one of the data types which we have in the Pythons, right? So if I just talk about list, so list is actually also having the same initialization, like basically we just put on the large brackets and we just initialize the list as well, right? And inside this also we can just put in numbers, whatever we just switch. So basically, what's the difference between an array and a list? Why we just use array? Why we prefer array over list? What is the differences? What are the similarities? And all that things, like basically, what's the idea of only and only using, like why we just prefer using array every time instead of the list, right? Many of you must be having this question, and if you're not having, then this question is from my side to you, that basically why we solve out this list, why we just only and only take arrays, why do not we take the list when we just want to use out the NumPy library, right? So basically I'll be ending this lecture at this question only, and will be giving you the answer in the next video. So basically till the time, always prefer array over list, right? Why we just use arrays in the NumPy libraries instead of list, right? So I hope that you have found out the answer till now. So it's my turn to give you the absolute and the correct answers for this question which I have taken in the last video. So just one second, here we go. So it's NumPy library, array and list. We're discussing about this thing, right? Let me just first of all put on the heading, that is list versus and its array. List versus array, right? Now I'll be letting you know about that. Basically, first of all, what is the similarity between the list and array? This is the very first thing that we are going to discuss. So I would be just writing here similarities. Okay, what are the similarities between both of them? So just one second, just let me quickly take another color and start up here. And okay, so the similarity comes that the first similarity is that they both store data, right? Both store data. Yes, we had seen even this thing in the previous video. I just told you this thing previous video as well, that basically the use of NumPy is to store some numbers, like they are basically initialized using the large brackets, right? And the same is for the list. So for the list also they are initialized using large bracket, and basically the work of this is to save some data, store some data. So this is the similarity which comes between the NumPy and the list. Moving towards the second one, they both are mutable. Now basically let me just tell you a little bit that what is mutable actually. So mutables, you can just say that that can change. Mutable actually refers that can change. So if you have like heard about the list, so in that case list are mutable. That is, like as soon as we have declared the list, after that we can just modify the list. Modify in the sense that if we just want to delete any element, we can delete. If we just want to add on any element, we can just add on, and all of these functions we can just perform on the list. And even in arrays also we can just perform all of these functions, that are, if you just want to add something you can add, if you just want to delete something you can delete, you can reshape, you can resize. So basically there are predefined functions for doing all of these things in arrays as well. So that is why the similarity is that both are mutable. So in that case basically both can change, both can be modified after they are declared, right? This is called actually what is mutable. Moving towards the third. So basically third one says that they can be, let me close this one, they can be indexed. Okay, they can be indexed. Now they can be indexed actually means that we can index the values. Now let's say I have declared a list and an array that is containing numbers, so I can index them, right? Let's say 0, then 1, then 2, then 3, then 4. I can just index them like this, right? This is the whole idea, that they can be indexed, that I can just provide them a particular position to all of these which I am having, right? Now moving towards the moving towards the fourth and the last similarity between both of these. So that comes that we can just perform some slicing operations. Now, what does this actually slicing mean? Slicing means that obtaining a sub part of your list or array or whatever the data you have taken. Okay, let's say I have taken a list and an array that are containing 5 numbers in that. Okay, now I would apply my slicing operation, and that will actually help me to get a small part of my array or list which I have declared. Okay. So this is the whole idea about the slicing which we just actually take. Right, so slicing operations are basically finding out a small part, a small area from the list or array which we have taken. Right, this is done. Now, basically, other than these are the 4 similarities which we have between the list and array. Okay, I would just come down now. I would just come down a little bit here, and let me take a new color and let me start with the differences. That basically what is the differences. Okay, so now I'll be defining the differences between the list and an array. Okay, so again that same color, fine. So the first difference is that they have different data types. Okay, let me just write it in this way: different data types. Now, what do I just actually mean from different data types? So, actually what happens is that when we just declare a list, so inside list we can define different data types. That is, we can define integer, we can define a character, we can define a string, we can define a float, we can define a complex number. All of these things you can define inside a list. But there is one case in the arrays that inside the arrays we can only and only define numbers. Have you ever seen an array of some characters or strings? No, right? Because we cannot define that thing. We can simply, what we can just do is that inside the array we can only and only take numbers, but this is not the case in list. In list what you can just do is that you can take n number of data types. I'm just not talking about numbers or particular strings. I am talking about data types. Data types are like what type of data you are giving. You are giving a string, you are giving integer, you are giving float, character, what type of data actually you are giving, right? So you can just take any data type inside a list. Let me just give you an example that how actually we just declare a list and how we declare a array. So let's say if I just take the example for a list. So here we just define the list inside the square brackets, right, that I have done. Now I can just write here 1. Let's say 1 is one of my integers that I have taken. Let's say I want to define a character. I can define a character. I want to, let's say, define a float. I can define a float. Again, I want to define a character. I can. So this is actually how we define a list. Okay. Second thing comes. Now if I take the example for an array. So inside the array I cannot write A 20.3 B or something like that. I can define only and only numbers inside that. Let's say 1, 2, 3, 4, 5. Let's say these are the numbers which I have taken. So this is actually how we define an array. Okay, so now I hope that you have got an idea that what is the basic difference between the arrays and the list. Right, this is done. Now let's see that basically advantages of array over list. This is the third topic that we are going to see. So I'm just going to write here advantages over advantages of array over list. Okay, advantages of array over list. Right. So now basically I'll be telling you that basically what are the advantages of array over list, right? Let's go on. So my first point comes here that less memory. So less memory. The first advantage, okay, just give me 1 minute and memory, let me write that. Fine. So the first thing that comes is that arrays have less memory. They occupy less memory than the list. And now what's the basic reason? Like I have told you that they occupy less memory. I have told you and you have listened. But what is the basically reason that why they actually require less memory? So understand it in this way. That previously only I have told you that what are the disadvantages, like what are the differences between the arrays and list, right? So in that case what I told you that array can only and only take the integers, right? And what about the list? Like list can store characters, list can store integers, list can store like floats, anything they can store. So in that case, when array is storing only and only integers, and at the same point when list is storing different data types, so in that case basically array would be occupying the less memory, right? Because we have only one single data type inside the array, right? But the same case is not in the list. List, what is it having? List is having many number of data types into it, right? Which basically makes it occupy more space than the arrays. Fine. So this is the main difference. So this is the main advantage of array over list, that that basically they occupy less memory, right? Moving towards the second thing. Now, basically, second thing is fast. Now, this is obvious. The same reason becomes here also, that if I'm just using simple one data type instead of many data types, so it would be fast. That is the thing. And moving towards the third, and yes, it is convenient to use, actually convenient to use. Why convenient to use? Basically because we have already seen about the arrays, like we just have dealt with 1D 2D arrays in our like schools or in our colleges, like. So in that case basically we are easy to understand about the arrays. We are basically easy to apply the operations on arrays, so that is basically convenient to use. Right. So now I hope that you have a fair and a clear idea in your mind that basically how to, like, what are the advantages of array over list, what are the similarities in list and array, what is the difference between the list and array. Right. So as we had already discussed about the list and array similarities, differences, why we prefer list over arrays. Sorry, why we prefer arrays over list. So now it's the time to go deeply inside into the topic, that is arrays, right? Now I will be properly focusing upon only and only arrays. So let me just put on that heading here. And first let's start with the definition, that actually what is an array. Okay, what is an array? So an array is basically a collection. Okay, array is a collection of elements. Okay, it is a collection of elements. Now the definition does not stop here. So array is a collection of elements of same type. Okay, of same type. This thing I have even told you when we were discussing about the list. So in that case I just told you that what actually array contains. So actually array contains only and only integers or floats, right? It basically only contains numbers. So it is basically a collection of elements of same type, right? This is about the array. Now basically what are the ways that we can have for defining the arrays, like basically how many, in basically what are the types which can be used for creating the arrays. Okay, so I'll be writing here that there are basically two ways. Okay, there are two ways to create an array, right? We'll be discussing about both of the ways right now. Okay, I'll be just branching it like this, right? So my first way goes that basically you can simply use the array module. Okay, you can simply using, I would be writing simply using array module. So the first thing goes that you can just simply use the array module and you can just declare an array. Second thing goes that numpy using numpy library. Second thing is that you can just use the numpy library and declare the array. So these are the two ways which you can use for creating an array. So first one goes like you can use an array module for creating an array, and second thing goes that you can simply use on numpy library for using and for creating the arrays, right? Now I will be moving towards the types of array that we'll be seeing here, right? So like focusedly I would be discussing about, okay, focusedly I would be discussing about the 1D arrays and the 2D arrays. So 1D array, okay, this is basically my one dimensional array that is basically having only single dimension. Okay, now how to basically declare the 1D arrays, how to initialize the 1D arrays, so I will be letting you know. So as mentioned and as you all also know, that basically arrays are always defined inside the large brackets, right? So there is no need to tell this thing again and again that we define the arrays inside the large brackets. So I just make this large brackets and let's say I just write 1, 2, 3, 4 and 5. Let's say these numbers. So this is actually how we declare a 1D array, that is a one dimensional array, that is basically having one dimension only, and here we have one dimension, that is only and only row. You can even define it in a way that let's say you just define it 1, 2, 3, 4, 5. You can just even define it in this way also. Okay, this will be having only one dimension as well, and that is column. Okay, this is the idea. Second thing goes that we have 2D arrays. Now, how to define 2D arrays when you're just simply writing out some program for 2D arrays? So, in that case, I just simply put one large bracket inside that one more. So I'll be writing, let's say 1, 2, 3, 4. Okay, this is basically how we declare a 2D array. And basically when you're just going to run this, like I'm just not running any program right now, but if you're just going to write any, storing this thing any variable and printing that, so it will be giving you the output like 1, 2, 3 and 4. You'll be getting an output like this. So this is basically how a 2D array looks like, right? It has basically n number of rows and n number of columns. Right, so this is how we just declare the 1D arrays and 2D arrays. So here I haven't like taken any particular variable and worked upon that. I simply told you how to initialize the 1D and the 2D arrays, and it's at some point you'll be seeing the multi-dimensions array as well. Okay, at some point you'll be seeing that. Firstly, we are going to discuss about the array, that basically how to declare an array. And if you just want to write a program for declaring an array 1D or 2D, so basically how we do that, right? Let's begin up here. So as this topic, this array, we are just going to use it the Numpy libraries. So whenever we just want to use any particular library, let's say it's Numpy, even if I'm talking about any random library as well, let's say you just take any pandas or a matplotlib, seaborn, any library, when you just want to use that library. So the first thing that you do is here, we just import that particular library onto the file in which you are working. Right, so here basically what I'll be doing is that I'll be importing my Numpy library. Okay, so for that I'll be simply writing the import. Import is one of the keywords that we have, and that is basically used for importing a particular library. Right, so import, and here I'll be using Numpy. This is basically how we import, but here one more thing comes, and that is particularly giving a short form to a library. Now basically what's the use of giving that short form to a library? That let's say this Numpy is a large name. If I just give it a short form, let's say NP. So wherever I just want to use my Numpy library, instead of writing this whole Numpy, I can simply write NP, and that will actually work for me, and that will actually refer to my Numpy library as well. Okay, so in that case I'm just going to write import Numpy as NP. Right, this is actually how we declare, how we import a library, and even just give a short form to that particular library. Right, I'm just hoping that you are just listening to me very carefully and even just writing all the programs, all the things, making all the notes properly. Right, so it's the time for coding, so just open your IDEs and start writing the codes with me. Right, now actually in Numpy library we have a function that is help. That's actually that HELP, right? Help. That is a very useful function, right? Now how it is useful? So as you just write help, and inside that you just write any function, now that will actually give you the whole idea that what actually that function does, and what are the things, what it returns, what are the parameters. But there is some exceptions that this help function do not apply on all of the functions which we have, but it usually applies on many of them. Okay, I would be letting you know that on which it applies, on which it not applies, how to use that, and all of that things. So I would be just using that help function first of all here. Now instead of using the whole Numpy word, I could simply use NP, right? And today we are going to see the array function, right? So in that case, I simply wrote np.array, and that I had wrote inside the help function. So if you are just on the PyCharm IDE, and if you just want to run any program, so what you just do the right click. So as soon as you do, you just get an option under the generate to run your file. Okay, run, and after that your file name. Just click on that, and here in the downside on the console, you'll be getting your whole output. Now, just let me zoom in and go above and show you that what it has actually given me as an answer. Fine, let me even just increase this one. Okay, so help on built-in function array module Numpy, so it is giving me array. Now, these are the parameters which you can pass inside the array function. That is your object, your data type, your copy, your order, your sub OK, and NDMN. Okay, these are the parameters which you can pass. And after that, you can just create an array. So even it is here giving all the details that what does this function does, what does the parameter does, what to pass here. So it is giving me object, it is array like. An array, any object exposing to the array interface of an object whose array method returns an array or any sequence, right? So here inside the object, you can just pass on any array. Data type you can just pass copy. Okay, these are many things which you can just pass on, okay? After this, basically there are some orders which we have. So I will not be discussing that orders right now, because in NumPy we have a specific function for that I'll be taking after some time. Okay, after some time I'll be taking. So yeah, and basically what it actually returns. Now this is the one more interesting thing that we can just check out from this help function. It basically gives me an output as an an array object satisfying the specified requirements, right? This is done, and I would just come down here, and there are many things, like there are some even examples as well which you can just follow out. Okay, so from this even you can just have a read of this, and you'll be getting to know more and more about the arrays. Okay, calm down. I would just now be commenting this help one, and now just come on to the next line here, and let's say I just want to declare my very first array. I just want to make a one dimension array. So how will I be doing that? Let's say I just take a variable, let's say that is a for me. Okay, so if you just want to declare an array, you would simply write np dot array, okay, and into the bracket you will just put the brackets. After that you will be using the large brackets and declaring your array. Let's say 1 2 3 4 5. Okay, let's say 1 2 3 4 5, right? This is how you declare an array. And if you just want to print your array which you have declared here right now, so what you do, you simply write out the print statement here. Okay, let me go the side, print, and then you simply write on here a, run it. So basically after running it, you will be getting your required output, and that is 1 2 3 4 5, your one dimension array which we have declared above. Right, this is how actually one dimension array looks like, right? Coming on to the next line, I would be declaring a 2D array as well. So b is equal to, that would be, I would again be writing np dot, okay, that is np dot array, and into the bracket I will be writing, let's say here 1 comma 2 comma, and here will be what, 3 comma 4. Okay, and I would simply be printing here as b. Fine. Okay, let me just comment out this statement so that it does not run right now. Absolutely. So here I'm just getting my 2D array, that is 1 2 3 4, right? I'm just getting that thing, right? This is actually how we declare the arrays. This is actually how we declare 1D array. This is how we actually declare 2D arrays in NumPy. Fine. Moving towards the next thing which we have here, I'll be commenting this line as well. Right here. Now basically what I'll be just doing is that, let's say I want to specify a particular data type. Okay, let's take a simple case here. Let's say I've defined a one dimension array. Okay, I've defined a one dimension array, and I just want that one dimension array to basically come into the complex form. Complex form, we all know that I plus j, right? AI plus bj, let's say. So this is a complex form. I want my array to come into the complex form, and I have declared a single 1D array. So how to do that, right? So first of all, I will be declaring one of my array. Let's say I've just taken np dot, and that is array. Okay, and in the bracket, let's say I just wrote okay, just 1 second. Right, let's say I just wrote 7 comma 8 comma 9 comma 6. Okay, let's say this is the thing which I have just written here. I want it to be into the complex form. Put a comma here, and with the putting of the semicolons, these are inverted commas, just write here that you want the complex form. Okay, and I would just print out my C here. Okay, I will just print out my C. And now if I just run it here and just have an output, that what it is giving. It is giving me 7 plus 0j, and then it is basically giving me 8 plus 0j, 9 plus 0j, and 6 plus 0j, right? So this is the complex form which actually comes. Absolutely right. So this is how you can just print a particular array into any particular data type, into any particular form, whichever you just want, right? Let me quickly summarize that what we have discussed. So we have discussed first of all how to import the NumPy library and give it a short form. So for that it was NumPy, import NumPy as np. Then we had seen that what's the use of the help function, how you can just get the all of the things that basically what the np.array does. So with that basically we had taken out the help function. So we had seen many things regarding the np.arrays, right? Then what I have done, I have taken a variable and declared the array into that variable. Right, I just simply taken a 1D array that was 1 2 3 4 5, and after that printed the 1D array. Then I have told you how you can just print a 2D array, right? And then even I have told you if you just want to change your change your array to a particular data type. Let's say I just wanted to change it to the complex form. So how you will be able to do that thing, right? So I hope that you have got a clear and a very fair idea that how you can just declare a 1D 2D array, change the basically data types and all those things, how you can do that. From today we are starting the functions, and that the first function which we are going to discuss today is the arange function. Okay, this is one of the functions which we have here in this numpy array. Now, what's the use of this function? The very first question that comes in all of your mind, that basically what's the use of this function? So here we go with the answer that numpy arange is one of the array creation routines based on numerical ranges. It creates an instance of ND array with evenly spaced values and returns the reference to it. So do not basically keep the whole definition in mind, which I have just written here. Just keep this thing in mind, that basically what's the function of arange. So arange basically help us to get the evenly spaced values and returns the reference to it, right? This is the idea about the arange function. So whenever it comes about the arange, only just remember that it helps us to get the evenly spaced values, right? Let me just let's come down here and start writing some programs, some functions, and then we'll be getting to know in a little bit more detail what is the actually use of this arange function. So the very first step comes here is that I'll be importing my numpy library. So for importing, I have already discussed in a very detail in the previous videos, right? So I'll be writing import numpy as np. Right, come on to the next line. Here basically I would be first of all using out my head function, so to check that basically how to use that arange function. I'll be writing np dot arange. Okay, I would be running my program here. So now basically it gives me that what's the use of this arange function and basically how to use it and what are the parameters which we have and all those things here. So arange is a function. Here basically we have parameters that are start, stop, step and data type. These are the parameters which we can give here. Now how to give these parameters, that I'll be letting you know in a little while. Okay. So now just come on there, and here are the parameters. Just you can just read that thing on your own. I'm just not going to define that right now because I would be explaining the whole in a very detail. So I'm just not going to read that again. Okay. And basically what does it actually returns? So this arange function which we have here, it actually returns me an ND array, that is array of evenly spaced values that I have mentioned in the previously some minutes before as well, that it actually gives us a evenly spaced value array. Okay, this is the whole idea. And after that basically here are some examples also that you can just see on your own afterwards, right? Let's move on with the program for here, and let me comment out this line right here. Now, I'll be taking one, let's say A is one of my variables, okay? np dot arange, okay? And inside the brackets. Now, just let me put one hash here and let me write out something. Okay, arange is the function, right? And inside this arange function, what we have? The first thing that we have a start parameter, right? Second thing, we have the stop parameter. Third thing, we have the skip parameter, and fourth thing, we have the dtype parameter. So these are the four parameters which we have seen right now, that our arange function consists of all of these. Right now, when I want to give a starting value, so what I would be just doing, I'd be giving a starting value. Let's say my starting value is 1. Okay, let's say this is my starting value. I want to give a stop value. So what I would just do, I would put a comma here. Let's say my stop value is 7. Right? This is one is my starting value and 7 is my stop value. Fine. Now what I would be doing, I would be simply printing out my A. Okay, and now I would be just running it here. So have a look. What I am getting, it started from 1. Okay, have a look that here I wrote that start from 1. So it started from 1. It gave me 1, 2, 3, 4, 5 and 6. It basically ended at 6 because what I have given a stop here as 7. Right, so in that case, it is giving me 6 values, that is 1, 2, 3, 4, 5, 6. Fine. Right, this is how actually arange function works. Now there is no need to define that you define some particular numbers, let's say 1, 2, 3, 4, 5, 6 here. If you just want to define a one dimension array, do not need to write all of the numbers. simply use this np.arange function, and in that just put out the condition that from which value you need to start and from which value you need to stop, and you will be getting the answer. Now let's say in the skip parameter I wrote 2 here. Okay, this first was my start, this is stop is my 7. Okay. Okay, let me just not discuss about this step here itself. I'm taking a new example for that. Let me just comment out it. Okay, right. Come here. I would just add on here. Let's say b. Okay, b is equal to. I'll be using np dot arange. Okay, np dot arange. Now, in the bracket, what I would be just doing is that I would be, let's say, giving out some float value. Let's say 5.0. Now what it will do, it will okay, I just haven't printed it, just give me 1 minute. I would just write here print and then b, right? Now if I basically run it, see, it automatically started from the 0th index. It automatically started from the 0th index, then 1, then 2, then 3, and then 4, and it ended up at 5. So if you are not, if you're basically giving only single value here, so it will automatically treat that single value, single parameter as the stop parameter. If you're not giving any particular thing, right? So it will automatically treat it as a stop, and it will actually treat like stop at that particular point, whatever you have given, and automatically start from the 0th index, right? Now, okay, let me close this one here and let me comment out this line. Now comes about the skip parameter. So let's say here C is equal to, I'll be writing here np dot arange. Okay, range, fine. Into the bracket, I'll be passing, let's say, here I want to pass, let's say 2. Yes, let's say 2, comma, and I want to give the ending value as 20, let's say. And now, what skip value I want to give here? Let's say skip value which I just want to give here is 2. Okay, this 2 is actually starting, like acting as my start value. This 20 is actually acting as my stop value, and this 2 is actually acting as a skip. Okay, and now what I would be just doing is that I would be simply using out my print statement and then the C, right? And now I would be running it here. So yes, have a look that basically now I just got all the terms from 2 till 20 with an interval of two numbers. Like I just first got 2, then I got 4, then I got 6, then I got 8, 10, 12, 14, 16, 18, right? So in this type of interval, I just got the numbers, right? So in that case, I just wrote here 2. So because of that, I just got the answer like this, right? Instead of 2, if I just wrote here 1, now if I just again try to run it, then have a look that I would be getting my whole array, that is 1, 2, 3, 4, 5 and up to n, right? Why if I basically if I've written 1 here, so why I'm just getting this whole array, like I am just any of the spaces, any of the numbers are not left here. So the reason is that it basically follows a rule, and that is n minus 1. So for this 1, n is acting as 1 itself, right? So 1 minus 1 is resulting as 0. So it means that not to leave any number between any of the numbers which you have mentioned here. So that was the reason that when I have written here as 2, this was the reason when I have written here as 2, I was getting the difference of one number after each and every number, because it also follows a rule, that is n minus 1. So for 2, basically n would be acting as 2 itself, right? So 2 minus 1 is 1. So it means that you need to leave one number after each and every number, right? So in that case, I'll be getting the answer like this, right? And now I would just again comment this thing for a while. Now, even if I just want to change out the data type, so in that case, I'll be taking d is equal to, I would be writing here np.arange, okay? In the bracket, let's say I just wrote a value that is 10, okay? I just mentioned the data type. Let's say now I just want it to be complex. Okay, complex is the data type which I just wanted. So I would simply print out my D here. Now when I would just run out my program once again, just have a look that I just got all of the numbers into the complex format, I plus j format, right? And when I just mentioned 10, so this 10 is automatically acting as a stop index, not the starting index. Please keep this thing in your mind that it is acting as a stopping index, not your starting index. Okay, so it will basically stop at 10 and it will automatically start with 0. So 0 till 9, and it basically printed me the complex form of all the numbers which I have written here, right? So now basically I hope that you have got a fair and a clear idea regarding the Arange function. Now just read out that it creates an instance of ND array with evenly spaced values and returns the reference to it. Right now I hope that you have a clear idea that basically what is the use of this Arange function, how to use this Arange function, what to apply, what not to apply, what are the parameters in this Arange function. Right, we'll begin to see the use of ones, zeros, and empty. These three functions in the NumPy library. Right, we had already seen that how to declare a NumPy array. Right, we had already seen this. Other than that, we had even seen one more function, that was arrange. Now today is basically the turn for seeing the zeros, ones, and empty function. So without I just do not want to quickly move on to the coding. Before that, I would just want to explain you that actually what are the use of these functions, that they come into this programming language and we just use them whenever we just want, right? So let's start up with a zeros function. So understand it in a way that a numpy.zeros function returns a new array of given shape and type with zeros. So whenever you just want an array, let's say you want an array, you want to do some functions with an array, in that basically you what you just want is that all the numbers whichever you are having, they all should be zeros only. Okay, so in that case basically the zeros function is used. So the work for the numpy zeros function is that it will give you a new array of whatever shape you just want, whatever type you just want, but what with the condition that each and every number will be filled out with the zeros only, right? This is the actually use of zeros function which we have in the NumPy arrays. Moving towards the function which is ones. Now understand for the ones that basically it returns a new array of given shape and data type where the element's value is set to 1. So ones is a function that will actually return you a new array that will be having only and only numbers which are 1. Right? So zeros and ones are actually a little bit same to each other, only differences regarding the numbers that will be coming inside the list. So in zeros, all the numbers, all the spaces, all the rows and columns whichever you will be having, that will be filled up with the zeros, right? And same for the ones, that all the rows and columns will be filled up with the ones in the ones function whenever you just use it, right? You can just set the shape according to you, you can just set the data type according to you. Only one condition applies, that is all the elements, okay, all the elements of that set will be will be 1, okay, right? So these both are discussed. Moving towards the next. Now, even we have another function which is the empty function. Now, what's the use of this empty function? So, it actually also returns a new array with a given shape and type, but it will basically have some random values. It do not have any fixed 1 value, or basically it do not have any fixed 0 values. It basically returns a new array and that will actually be having some random values. Okay, this is the whole idea regarding these three functions in the NumPy library. Now let's move towards the coding and let's code a little bit and see that how these functions work, how to use out these functions, what are the things do we have in these functions, right? So get started with your PyCharm IDEs for now. So the very first thing, whenever I just want to use in library, see, these are all the functions which come under the NumPy library, right? So I just want to firstly use out my NumPy library. So for that, what I'll be just doing is that I'll be importing that particular library. So import NumPy as np. This goes here, right? Now next thing I'll be using out my help function. So I have to check first of all my zeros function, np.zeros. Okay, I would just run out my program here. Let's run it. Fine. So let me just increase the size and let me go like this here. Fine. Now basically it is saying me that the zeros function which you have here, it basically have the shape, data type and the order. Okay, so basically what does it returns to us? It returns a new array of given shape and type filled with zeros. As I mentioned that whatever the elements will be inside that array, that will be filled up with zeros and zeros only, right? Other than these are parameters which you can just read out on your own. And what it returns the array of zeros with given shape, data type and order. You can just also look at these and you can just look at the examples as well, right? So now I would just close the output for a while here, and I would just start writing my program, which I just wanted to show you all, right? Okay, just 1 second. Let me just remove this one right here. Now I would be taking, let's say a is one of my variables which I have taken here, right? After that, I just want that np dot zeros. Now, inside this np dot zeros, I will be writing the number that basically how many elements will be inside the array. Okay, and I would just simply print out my a here, the variable in which I have written that how many zeros actually I want. So now just have a look that I have given only one value for the parameter. So that is why it is giving me one dimension. Other than that, I am having 6 elements here, and all the 6 elements are zeros. As I mentioned that zeros function will make all of the elements only and only 0. It will not return you any other element except the 0. Right? So here it is about the zeros function. Now let me just quickly comment out both of these lines. Now let's move towards the another example. Let's say I took a variable that is b is equal to. Here I use np dot zeros, let's say. Okay. In the bracket, let's say I just wrote 4. And I just want a particular data type, let's say. Okay. My data type is, let's say, integer, int. Okay. Let's say I just want this data type. And I would simply print out the b here, right? And I would just now run out my program. That will basically, now have a look that I just mentioned 4. So in that case, I'm just getting 400. Other than that, I mentioned my data type as int, right? I mentioned my data type as int. So in that case, basically, now it is giving me integer values. Previously, it was by default giving me the float values, right? Because I have mentioned that thing, right? Okay, let me now just comment out this line as well. Other than that, now if we just want a 2D array, okay, till now we had only seen regarding the 1D array. Now let's say you just want a 2D array as well. So now what you'll be doing, let's say I would be taking here as c is equal to np dot zeros. Okay, I would put one bracket. Other than that, I would even put one more bracket. Now let's say I want an array of 2, 3. Okay, that must have 2 rows and 3 columns. Okay, let's say I just want this, and so I would just print out here print c. Now when I would just run out my program, just have a look here that I am getting 2 rows, right? 2 rows I am getting, and other than that I am getting here 3 columns, right? So this is actually how we just like try to run out the things in the zeros function, right? And yes, this 2, 3 goes like this, fine. And even if I just like comment this line, and instead of this double brackets, let me just show you one more thing. D is equal to np dot zeros, this one and this large bracket. Inside this I will just write 2, 3, and here I just print out the d, right? If I just do it like this, then basically then also it will be giving me like the same thing, only the differences of the brackets. Other than that, basically we do not have any such difference, right? Fine. This is how the zeros function work, right? I hope that you have got a clear and a fair idea that how does this actually zeros function works. Now it's the turn for the function that is ones. Okay, now I'll be seeing that how ones function actually work. So let me just begin up with this like this file only. Let me just make it here, right? Now we'll be discussing about the one. So let's say I made a variable that is a. Before that, let me check out using the help np dot ones. Okay, and now I would just run out my program here, right here. So basically here I am just getting each and every detail regarding my ones function which I am going to use, right? So it is giving me the shape, it is giving me the data type, even giving me the order, right? That these are the parameters which you need to pass on in the ones. Or everything just remains same. I mentioned the starting as well as I'm just again telling you that each and everything will actually be remaining same. Only the difference will be it would be giving you all the zeros in the array. This ones function will be giving you all the ones in the array. Other than that, there is no such difference between both of these, right? So I'm just not reading the whole. You can just read that on your own, right? I would just simply comment out this line and simply took a variable. Let's say a is equal to, and that would be np dot ones. Okay, in the bracket, let's say I wrote 5. Okay, and I simply want to print here a. So basically here what I would be getting, I would be getting a 1D array that will contain 5 ones into it, right? So you are able to see I'm just getting 5 1 here, right? So I just gave one parameter, so because of that I am getting only 1D array. So for 2D also, now by the time you have understood that if it is want a 2D array, then what to do? So we have just seen this thing in the zeros function as well, right? Okay. So this print A is done, other than that if it is commented here. And let's say I just want to print the 2D array. Again, I would just use B is equal to np dot ones, and let's say in the bracket I just want to pass 3 comma 3. Okay, 3 comma 3 matrix. I just want, sorry, array I want to print, and here I'll be using print and then the B. And now if we just run here, so I'll be getting 3 rows and 3 columns, and that will be containing only and only one. Just have a look here like this. Okay. So this is the idea how you can just use out this ones function. Even if you just want to apply some particular data type, so I would just put a comma here and I would just write d type is equal to integer. Okay, and I would again run it here. Now I'm just getting my whole array of integers and integers only. It is containing only integers, right? Fine. Now let's come to the last function, and that function is basically my empty function, right? Let's see that what actually that function contains. So again, I would just simply write help, and in that I would be writing np dot empty. This one, right? I would just remove the bracket. No use of that. Fine. So basically what it is actually giving me, just telling me that you have the parameters with a shape, data type, float and order, right? And what does it actually returns? It returns a new array of given shape and type without initializing entries, right? So you can just have a look over the examples and write out which is there. For the time, I would just explain you the clear example that what actually it does. Okay, just 1 second, and let me just comment this line right here. So let's say I just took a variable a and I just wrote np dot, and that is basically empty. Okay, into the bracket I just wrote, let's say 6, right? And I would just print out a here, int a, and I would just run this program here for a while. Now just have a look that I am getting some random values here, right? This was actually the use of the empty function which I had told you in the starting. Let me show you that thing where I had written. So here it goes that empty function returns a new array of given shape and type with random values, right? This was the thing which I have mentioned here, that it basically returns you, it will return you a new array of a given shape, whatever you just mentioned, but it will be some random values. And here you are able to see that yes, it is some random values. Let's say it is 6.23, then 1.42, 1.39, 1.11, 4.84, something, many values, right? So it is basically how this empty function actually works, right? Now what I would be just doing is that I would be telling you regarding the 2D array as well. So b is equal to, I will be writing np dot empty, and this is round brackets, then the square, and let's say if I just wrote 2 comma 2, that is my 2 cross 2 array, right? And I would even initialize a particular data type. Let's say that is integer for me. I just want to print the integer array. And inside the print statement, I would simply write out the B here. Now let me just quickly run it once again here. So yes, here you are able to see some random value array, and it is basically having some like integers. Instead of the float, it is having integers, right? So that is because I have given a data type is equal to integer. And I have particularly mentioned 2 cross 2. So because of that, here I am getting 2 rows and 2 columns, right? So this is basically how ones, zeros and empty function actually works, right? I hope I made this thing very clear to you that what is the use of these functions, why are these functions used, and how to use these functions in the Numpy library. Now today we are going to see about the Linspace function. This is another function which comes under the Numpy library. So this is also a function which is basically acted upon the arrays, and we just like try to apply this function on the arrays for making it more useful and all that things. So before like seeing that how to write the code, what does it actually like how to write the thing, how to declare and all that things, let's firstly move on to the use of this function. Let's see that basically why this function is actually used, right? So let's begin up here. So it says, the definition which I have written, it says that Linspace function returns evenly spaced numbers over a specified interval. So basically let's say basically you want a evenly spaced numbers. Okay, let's say basically we have given a particular interval, and in that interval itself you just want to put evenly spaced numbers, like, okay. So in that case basically we just use out this Linspace function. This is the use of Linspace function which we actually do here, right? So basically, maybe it must not be very much clear to you that what I just meant from return evenly spaced numbers, but as soon as I'm just going to write the program for it, then you'll be getting a more clear and a more fair idea that what I just meant from this word, which is evenly spaced numbers. Right, let's move on with the things for you. So I just mentioned that this is a function which comes under the Numpy library. Okay, so for that basically what I just need to do is that very first thing I need to import my Numpy library. Correct? So import, I'll be writing here Numpy as NP. I've just imported my Numpy library and it's been given to very short form which is NP. After that, I just simply wanted to use my help function for the very first so that I can just get an idea that what is this actually used for. So help np.linspace, okay, and I would just run out my program here. So basically it will give me all the information regarding the function here, and here we have it, right? So the parameters which we have in the Linspace function are start, stop, num, endpoint, rate step, dtype, and the access. Right? These are all the parameters which we have in the Linspace function. Now, basically what it returns us evenly spaced numbers over a specified interval. Right? So interval can be given in the start and stop parameters. Right? Now, let's come down here and have a look about the parameters which we have here. So, start, array like the starting value of the sequence, and stop will be the ending value of the sequence, as I mentioned that same thing, right? Other than that, basically these are all the things which you can just read that on your own. Yeah, what does it actually returns? It actually returns the ND array, right? These are the things which is written here. You can just read that on your own as well. And other than that, basically here are examples which you can just look out afterwards. You just watch out this video. Right, so basically I'll be commenting out this help line and moving towards the next line for now. So let's say I took a variable that is a. Okay, let's say a is one of the variables which I have taken. So a is equal to np dot linspace. Okay, np dot linspace. Now in the bracket I'll be giving some start value, I'll be giving some stopping value as well. Okay, so let me just write down that. So let's say 1 is my start value. Okay, other than that, let's say 40 is my stopping value. Okay, and we even have one parameter that is num, right? Let's say in num I just give it 5 here, right? And I would simply print out the a. Okay, just let me take this line above here, right? I would just run it. Now just have a look at what actually I am getting. Let me just come down from here to here. See, I am getting 1. Okay, after 1 point, I'm getting 10.75, then 20.5, then 30.25, and then 40. So, within a range of 1 till 40, it is giving me 5 numbers. You're able to see that within a range of 1 till 40, it is giving me 5 numbers. So, num is equal to 5. I have written that num is equal to 5, right? So, it is giving me 5 numbers. And what is the main thing about these 5 numbers? That these 5 numbers are equally basically the number which is basically like if you just calculate the gap between these numbers, so it would be the equal for each and every number which you are having. So what was written? It returns evenly spaced numbers, as I mentioned. So the space which is between two numbers which you are able to see, they will be having the even space. That is all the space for each and every number between each and every number will be actually same to each other, right? So this is the actually use of Linspace function, right? Okay. Let me just quickly put on the. Okay, let me just. Okay, just 1 second. Let me come down. Let me just comment out this print statement, and let me just comment out this statement right here. Okay. Let's see another example as well. So if I just write, let's say b is equal to, and I just write np dot linspace, okay, in the bracket, let's say I just give 1, and let's say my ending value is, let's say, 40, same, okay, instead of 40 let me take it to 50 right now. Okay, I would just put again one comma. Let's say I just want now, let's say 5 numbers. 5 would be okay, right? Now we were having one more parameter which was endpoint, right? So in that case, I'm just gonna give endpoint is equal to, and it would be false for me. Okay, so endpoint false, that I do not want the endpoint to be included here. Okay, and I would simply print out B here, right? I would just run out my program now. Right here, so basically have a look that what I am just getting here. I am getting, again I am getting 5 values here, right? So num is equal to 5. But what is the case here? The case is that my ending value, which is 50, which is not included here. Why? Because I have written endpoint is equal to false. So in this case, I do not want my endpoint to be included here in this output, in this array which I am getting. Right, I'm just getting 1, then I'm getting 10, then 20, then 40, then 30, then 40. So I am getting evenly spaced values, right? So this is the whole idea behind using this Linspace function. I will just again comment this out. Other than that, basically, what do I have? I have data type. Okay, so in that case, let's say I just wrote C is equal to, and I just wrote np dot linspace, right? And into the bracket, let's say I just wrote 1 comma, let's say 10, and let's say I just want to give out my data type as integer. Okay, let me just write it out like this, int, right? And I would just print out this C, print, and in the bracket C. And let's say the numbers I would not be giving any numbers right now. Okay, let it be right there, like this, is even. Right. So basically what it is printing me all the numbers here into the integer format only. And basically what it is giving me 1, 2, 3, 4, 5, 6. It is printing me all the numbers at a particular, like basically at a particular like times. Okay. What I would be just doing here is that, let's say now I just want to give out the num value. Let's say I just gave the num value as 2. Right. And now if I just try to run out my program. Let me run out my program now. See, basically now what it is giving me, it is giving me 1 comma 10. So okay, so if between this one and this 1 comma 2, basically it is giving me two numbers which are having the equal space between these numbers, and I'm just getting two numbers which are 1 comma 10, and the integer is sorry, the data type is integer, right? Okay, let me just comment out this print statement as well once more here, and now I would be taking the last example for the Linspace function with another parameter. So let's say d is equal to np dot linspace, okay, and into the bracket I just pass 1 comma 50 comma, let's say I just wrote num is equal to 5, the same example, okay. Let me just come down first, right, and let me put a comma, and we have another parameter that is ret step. Okay, and I would just make it as true here, let's say, right? And let me just print out d here, and now just let me quickly run out my program for a while. Okay, so basically what do you just see that basically it gave me array, right? And other than that, basically what it gave me, it told me that basically how much space, basically how much equal space this has taken between each and every number. So it has taken 12.25, this much of gap of the numbers after each and every number. So after 1 it has taken 12.25 number gap, and then it printed me 13.25. Again after 13.25 it had taken a 12.25 number gap, and then it is printing me 25.5, and so on like this till 50, right? So this is the whole idea which comes here with the use of Linspace function, right? So when I just told you definition for the Linspace function, that it returns evenly spaced number over a specified interval. So this is the main use of the Linspace function which we have in this Numpy library. Right, so I hope I just made this thing very clear to you that how do we just use this Linspace function whenever we just want to declare an array and all the things, right? So we'll be seeing two similar functions, like we had seen some similar functions in the zeros and ones, right? Like that only, we have two functions which are identity function and the I function. That is, yes, you heard that right. It is I, E-Y-E. Okay. So basically these are the two types of functions which we are going to discuss today. So without diving into the code, let me just quickly explain you that what is the use of identity and what is the use of I function. What are they basically used for in the arrays. Okay, let me just explain you that thing. After that, we'll be moving towards the coding thing. So here comes about the identity function first of all. So identity function return the identity array. Okay, now you all know that what is identity array, right? We had studied all of these things into our schools itself, that we were just like told, okay, that this is the identity array and all those things. Just treat it in a way the identity matrix. Okay, compare it with the matrix as well. So we had seen about the identity matrix, that it was a square and that was having ones onto its diagonals, right? That is the identity matrix. So identity array is also the same thing only. So identity array is a square array with ones on the main diagonal. Okay, the main diagonal which we are having, onto that main diagonal we have ones. So that is actually called as an identity array. Now what is the use of the I function? Okay, so identity function returns you an identity array. That is very much clear, right? Move on to the I function. So basically I function returns a 2D array. Okay, it basically returns a two-dimensional array with ones as a diagonal and zeros elsewhere. Okay, so I is a function. Now basically just have a look over this thing, that I actually works on the 2D arrays only. It basically will return you the 2D array only, right? So it returns a 2D array which have 1 into their diagonal, right, and zeros on all of the other spaces except the diagonal, right? These are the two functions which we are going to discuss today. So I hope I made this thing very clear to you, that what is the use of identity and what is the use of I function. Right, now let's dive into the coding and then see that how to use these functions with the help of the arrays. So the very first step, which I always repeat, and right now I'm again gonna do that thing. So I would be importing my Numpy library first of all, because these are the functions which come into the Numpy library. I'll be using it with the Numpy library. So in that case, it's very important for me to import my Numpy library. If I'm not gonna do that thing, it will basically result me the error. Okay, so make sure to always, whenever you just use any function from any of the library, it's not only for Numpy, I'm just talking about any library, any particular library you are just like dealing with. So make sure to always basically import that library first of all, and then only just use it. Okay, right here. So I'll be writing import Numpy as np right here. Okay, I would just come on to the next line. So first of all, I'll be using my help again, help function. So help np.I. Okay, and now I would just run out my program here. Okay, let me just go above and zoom in a little so that you are able to clearly see everything. So I is this function. Basically, what are the parameters which basically it has? So parameters are in, m, k, d type, order. Okay, so these are the parameters which we have, and what it returns? It returns a 2D array with ones on the diagonal and zeros elsewhere, right? Now, what is this n actually referring to? So this n is actually referring to the integer. M is also referring to the integer. But what's the difference? So in n, basically, you will give the number of rows. Okay. And in m, basically, you will be entering the number of columns. Okay. This is the difference between both of these, n and m. Okay. Please make sure to remember this thing. Do not forget it while writing the code. Okay. Fine. Other than that, we had k, that is the index of the diagonal. Okay. Other than that, basically, what it returns, that I just already told you, that it returns an empty array of shape n comma m. What are the values you're going to give in the n and m? It will basically result you the array of that shape itself, right? Other than that, these are the things which you can just read on your own. Check out the examples as well. So here, let's move into the code and let's write out some things for this I function. Let me comment out this line here. Right. So basically, what I would be just doing is that I would be taking a variable here. Let's say that is a. Okay. So I just wrote np.I, and in the bracket, let's say I simply wrote 3. Other than that, I just did not wrote anything. Simply I just wrote 3, and I want to print out the a. Now when I would just run out my program here, see what I got. I got a 3 cross 3 matrix in which the main diagonal is covered with the number that is 1. Other than that, at each and every place, I have the element which is 0. Right? And yes, this was the thing which I just mentioned in the very starting regarding the definition of the I function, that what it actually does. It actually returns us a 2D array with 1 at the main diagonal, and other than that, at each and every position, it only has zeros. Right? So this is basically how this I function actually works. So A is equal to np dot I, and in bracket I just wrote 3. So at the main diagonal, that is at the 3 positions of the diagonal, it just gave me the number that is 1. Other than that, each and every place it gave me 0. Right? I would just comment out here. Fine. Next thing. Now if I just pass on two values. Right now it's pass single one value. Right? Okay. Let's take it for B. Okay. B is equal to np dot I, and in the bracket I see, let's say I just pass 4 comma 5. Okay, and I just simply print out here B, right? And now I would run my program. Just wait a while here, and yes, now have a look at first of all I just passed 4 comma 5. 4 is actually referring to n according to the parameters, the syntax which we have seen. 4 is referring to n and 5 is referring to m. Hold on, let me just write out that thing here because it's very important to understand. Right? So what syntax we were having? We were having I. Into that, what we were just having? N. After that, we were having m. So now this n was the number of rows. I would write number of rows. Okay. And what was m? M was number of columns, right? So number of rows and number of columns. So rows I am having here as 4 and columns I am having here as 5. So check out the output which I have just got out here. Okay, let me increase the size here like this. Fine. So I'm getting here 4 rows, right? I'm just having here 4 rows and my columns are 5 because I have just given that particular thing that I want 4 columns, 4 rows and 5 columns, right? That I have mentioned here inside this brackets which is 4 comma 5. Other than that, on the diagonal, I am getting the number as 1, and other than that, at each and every place, I am simply getting only and only 0, right? So this is the whole idea regarding the I function for the 2D array as well. For 2D array, if you just want to define your particular size, particular shape, that you want this much number of rows and this much number of columns, so how you are going to do that thing, right? That I have explained you right now. Other than that, let's move on with the more things we have here. So B is done. After that, I would take the variable which is C. I would write np dot I. Okay. In the bracket, let's simply pass 3 as value. Let's not go into very much deeper. Let me just pass the 3 same number. Now, you're having one more parameter that was k, right? And in k, let's say I just give some negative value. And I just print out the C here. Now, if I run my program, okay. Now, understand this thing very carefully that basically the diagonal was these three. Okay, these three were diagonal, but in the diagonal I'm not getting the value which is 1. Why? Because I have given the value for k as -1. Now if I am gonna give the value as -1, so basically my diagonal will shift to downside the main diagonal. And if I am going to give the positive value for k, that is k is equal to +1, then basically the value for my 1, that is my diagonal, will shift 1 above the main diagonal, right? You know that what is the main diagonal, right? 0 comma 0, 1 comma 1 and 2 comma 2. These are the places where we have the main diagonal, right? Now if I just give the value as -1, so it will go downside my main diagonal. And if I just give the positive value for k, it will go above side my diagonal, right? So this is the whole idea behind giving the values for k. Now if I just remove out this 1, okay, if I remove out the value for minus and I again rerun my program, now just have a look at my diagonal, main diagonal, which is 1. Now it has been actually shifted upwards. It has been shifted above the main diagonal because I have given a positive value for the k. Okay, so because of that, it has actually been shifted at the top side, right? So I hope you have got a clear and a fair idea, if you have listened me very carefully, that what does this k parameter actually does. Right, I would just comment out this print statement here for a while and let's move on with the another example. Let's say now I just want to give another variable which is d. Okay. After that, I would write np dot I. Right, in the bracket, okay, here is my bracket. Let's I just pass here 4. Okay, I want to give some value for k as well. So k is equal to 2. And even I just want to give a particular data type. Let's say my data type is integer. Okay, and I would just print out my d here, right? And now I would run out the program. So basically, have a look here that what I am getting. First of all, I am just getting 4 rows and 4 columns, right? 4 rows and 4 columns because I have given the value here as 4. So that will have to automatically print me 4 rows and 4 columns. Other than that, basically, here I have given the value for k is equal to 2. So from a main diagonal, it will shift 2 positions above. Okay, from my main diagonal, listen very carefully, I have given a positive value to k. So from my main diagonal that I am having here, it will shift 2 positions above, right? So that is the reason that I am getting the values for 1 here this place. Okay, now next thing comes, if I give out the negative value. Okay, so in that negative value, if I just write -2, so it will shift 2 position downwards my rear diagonal. The rear diagonal, like basically the rear diagonal which we are having here, it will shift 2 position downward from that place. Okay, right. Let me just now close it, and the data type was integer. So in that case, basically I was getting the integer values. Fine. Let me comment out this thing. So this was all about the I function. Now we were having one more function which is identity function. So identity function is a square array with ones on the main diagonal, right? Let me show you how to use out that identity function. So if I just wrote, okay, if I just write help and I just wrote np dot identity, okay, and I would just run it right here. So basically, here I am getting that identity function is actually having the parameters which is n and the data type, that is okay, and it basically results in the identity array. So what is an identity array? So the identity array, okay, identity array is a square array with ones on the main diagonal. So it will be having basically 1 on the main diagonal, right? Other than that, you can just read out the parameters on your own, whatever you just wish, and what it returns, it basically returns an nd array. Okay, and this is the example which you can just have a look afterwards. After you are just finished up with this video, you can have a look over that. Let me comment out this and start off with the basically the identity array. So okay, till d elements, d variables, let me just take it here as e, right? So if I just write np dot identity, okay, if I just write np dot identity in the bracket, let's say I just gave a value as 3, okay, and I want to give a data type as let's say integer. Simply write int as like this. And basically what's next, I just want to print out this e in which basically I have stored my identity array. Okay, now I would run it here. Just have a look that I just passed the value for 3, so it is giving me the basically the array for 3 cross 3. Other than that, what it is giving me? Other than that, it is giving me the value that is 1. Okay, it is giving me 1 on the diagonal, 1 on the diagonal, and rest all the spaces which are here, that are 0 here, right? The 0, 0, 0, and here all the 3 0 as 0, 0, right? So basically, this is actually how the identity array works. Instead of this 3, if I just make it to 2, and now if I just again run it, it will be giving me a 2 cross 2 array, that is 1 0 0 1. Okay, and it is having 2 rows and 2 columns, right? So I hope I made this thing very clear to you, that how to use out the identity and how to use out the I function. So let me just quickly give you an overview about the discussion which we have done. So identity function returns the identity array. And what is an identity array? So basically it is a square array with ones on the main diagonal, right? Other than that, what is the I function? So I function returns a two-dimensional array with ones as the diagonal and zeros elsewhere. Right? So I hope I made this thing very clear to you, that how to use out this identity and I function if you just want to use these functions with the array in the NumPy library. Right? Basically, now today we are going to discuss about the attributes of array. Now I will be telling you about some attributes of array which basically are very helpful, in like checking out the arrays and all those things. Right? I will be letting you know about each and everything in a very detail. So let's begin up here. So what I will be just doing is that firstly I will be importing my NumPy library. So basically this time I do not have any definition or any write-up because it's very easy. Like the functions which I'm just going to tell you, they are direct functions. Okay, so because I'm just not going to tell you a particular function, any function which is used in the library, but I'm just telling you that how to check out the shape, how to check out the size and all those things, right? That only I'm just going to tell you. So the very first thing that I'll be doing is that I'll be importing my NumPy library. So for that I'll be writing import NumPy as NP. Now NP is the short form to that NumPy library that I have given here, right? So that I have done. After that, my first topic which comes to me is checking out the dimension. Let's say I have made a array. Okay, let's say I have a array. Now I want to check the dimension of that array. That it is a 1D array, it is a 2D array, 3D array, what type of array it is actually, right? So in that case, I would be using a function and that function is called ndim, that is n dimension. But we do not write the whole dimension, we simply write dim, ndim, that is ndim. Okay, let me show you basically how we just use that thing. So for the first thing, I will be taking a variable that is, let's say, a. Okay, a is one of the variables which I have taken here. After that, I will be making an array. So np dot array. Okay, I will be putting the brackets and the large brackets inside this. Let's say I just pass the values 1, 2, 3, 4, 5. Okay, these are the values which I have passed. And I want to check the dimension for this array which I have written here. Okay, I want to check the dimension. So what I would be just doing is that inside my print statement, I'll be writing the variable in which I have stored my dimension for, the variable in which I have stored my array. So first of all, that is a for me, right? Dot. And I would be using ndim, that is my n dimension function, right? I'll be using that and now I would run my program. So basically have a look at what it is giving me as an output. So it is giving me as an output that your dimension for the array which you have declared is 1. Okay. So I'm just getting the dimension here as 1. That is okay. Let me comment out this line. Moving towards the second thing which I have, let me take another example. Let's say I just gave a variable that is b. Okay, now into this b variable, basically what I would be just doing is that, let's say I'll be writing np dot array. Okay, in the bracket I would be passing, let's say, two dimension array. That is, let's say 1 comma 2. I would be 1 comma 2. After that, I'm putting a bracket and let's say it is 3 comma 4. I'll be doing that thing, right? And simply I would be using out my print statement print, and that is b dot n dimension, b dot ndim, and I would just running out my program. So basically now have a look that it is giving me that, okay, your basically the array which you have declared here, it is of 2 dimensions, so it is your 2D array, right? So this is actually how we just print out the dimensions of the array. If I just want to check out that how it look like, so I would just write the print, and inside that print, okay, instead of a I'll be writing here as b as well, right? And now I'll be running out my program. So have a look, it is giving me that basically your array which you have taken, that is a 2D array, and other than that basically it is coming up like a 2D array which is having the elements as 1, 2, 3 and 4. These 4 elements it is actually having, right? I would just close this, fine. So this is actually how we just check out the dimension for a particular array which you have made. Now next attribute which we are going to discuss, which comes is that basically how you will be like making out the shape. I will be checking out the shape. Okay, so in that case, let me just put on the heading first of all, that is here shape. Okay, come on to the next line. I would be defining a variable here. Let's say that variable here for me is a. Okay, and after that I'll be writing np dot array. Okay, and into the bracket I will be again defining, let's say, a 2D array, and I'll just put one more bracket. Let's say 1 comma 2, and that is 3 comma 4. Okay, let's say this is the array which I have actually defined here. Right now, what's the next task for me? So I need to use out my shape function. So as I mentioned that we'll be checking that what is the shape of the array which you have taken. So in that case, basically you will be needing out the shape function. Okay, so print in bracket it is a dot shape. Okay, have I commented the above things? Let me just check out. Yes, I have. So now I would just run out my program here, and now it will be giving me that what is the shape. Shape actually refers to the number of rows and the number of columns that your array is actually having. Okay, so I am getting that your array is actually having 2 rows and 2 columns, that is 2 comma 2, right? So yeah, that is the same, that is the correct thing, right? I am having a 2D array and that consists 2 rows and 2 columns, right? Fine. So shape is also done. Other than that, I want to check out the data type as well. Let's say I want to check out that what data type my array is actually having. So I would just write down here as data type, right? I would just come on to the next line and I would again run out my program. Okay, sorry, before running, let me just quickly write out something so that I can show you that right here. So the first thing that I would be doing is that I would be defining a particular variable, right? So let's say I would be taking now, let's say b. Okay, b is equal to, and okay, I would not be taking any particular variable. I'll be taking it for the previous ones only which we have made till now. Okay, so I'll be writing the print statement. Inside that I'll be writing the name of the variable for which I want to check out the data type. So I just took it here as a, let's say, and I would be using the d type. Okay, and this is the function. And now let me quickly run out here. Fine. So basically what it is giving me, it is giving me that the data type for your function, for your variable, that is a, in which you have stored a 2D array is integer 32. That is integer. Take it as integer only for now. Okay. So it is giving me that your data type is integer. So this thing is also done. And now we are left with the last attribute, that is basically I want to check out the item size. That what is the size for my item which I am having here, right? So for that, basically, I would be using a function that is actually called as item size. So I would not be defining any new array or something like that. Simply in the print statement only, I'd be using the variable that is a itself. Like we have just declared this variable above side, right? So now I would not be declaring a new variable. So a dot, and here I would be using item and the size like this. A dot item size. And now I would be running this again. So it is basically that it is giving me that, okay, you have total 4 elements in your array which you have made. So here I have made the array in the variable which is a, right? And now here I am having 4 elements. It is absolutely true because it is a 2D array of a 2 cross 2 matrix. So a 2 cross 2 array, and it is having 4 elements, 1, 2 and 3, 4. Right? So in that case, it is giving me that basically you are having your item size as 4. That is total number of items, total number of numbers which you are having. So these are some attributes in the Numpy library which actually help you basically check out and get a more info about your array which you have declared, right? These were like dimension, shape, data type and item size. It basically helps you to get out all of these information for your array which you have declared, right? So I hope I just made this thing very clear to you that how you can just check out and apply some attributes, check out some more functions of your array which you have declared and gain more knowledge about the array which you have made. Today we are going to discuss about indexing in the Numpy arrays. Now I'll be telling you that basically how we can just do indexing in the Numpy arrays and how we can just like write out the code and all those things in the arrays for the indexing. Right, before diving into the code, basically what I just wanted is that I just want to explain you a little bit of concept regarding the indexing. I just want to explain you a little bit that what indexing is actually and how do we just give a position and give an index to all the particular numbers which we have in the array, right? So for that I'll be moving on to the OneNote for now, and basically I'll be putting on to the draw and I would be writing here take a color, right? Let's say I just simply defined an array. Let's say that array is 1. Okay, let's not take this 1, 2, 3 because it's very common. Let me take it as 9, 8, 7, 6 and 5. Let's say this is the array which I have taken here. Okay. Now, understand it in a way that whenever you are just going to do the indexing. So, index always and always starts with the number that is 0. Okay. So, you are dealing with the integers, you are dealing with the characters, you are dealing with the strings, whatever you are just dealing with. Make sure to remember this thing that indexing always starts up with the number that is 0. Okay. So in the place of 9, I will be putting the index that is 0. This is 1, this is 2, this is 3 and this is 4. So at the 0th index, okay, at the 0th index, I have the number which is 9. At the first index, I have a number that is 8. At the second index, I have a number that is 7. At the third index, I have a number that is 6. And at the fourth index, I have a number that is 5. Okay, basically, this is how we just do the indexing for the numbers in the NumPy array. If I just write a of 1, if I just write a of 1, so for this I will be getting the answer that is 8. So because at the first position I am having the number, I am having the integer that is 8. Okay, so I hope that you have got a clear and a fair idea regarding the indexing things. Okay, that basically how we just do out the indexing. I hope that you have got a clearer idea. Okay, I'm sorry for that. Now let's begin out with the code for now. So very first thing is that I'll be importing my NumPy library. So import NumPy as NP. Right, I'll be importing out my NumPy library. Fine. So basically after this, what I'll be doing is that I'll be taking a variable, okay, a variable, and then I'll be taking np dot, and I'll be writing here as array. A is equal to np dot array. That is okay, right? That you all know. Fine. Now I'll be putting the bracket, and let's see inside this bracket I'll be taking the same numbers which I have taken previously. 9, 8, 7, 6, 5. Okay, these are the numbers which I have taken previously. So as to explain it, so I'll be taking the same as well here also. Okay, come on to the next line. First of all, let's see if I just want to print that A. Okay, let's say if I just want to print out that, just one second. Let's say I want to print out A. I would simply write print and then A. That thing you all know actually, but I just want to revise it once more. So here we just got out the index which we were having previously, that is 9765. Okay, I would just comment out this thing for, okay, just one second. I would comment out this thing for a while. Come on to the next line. Let's say I want to just access the number which I am having at the first index of this array which I have declared. Right, I want to access that number which I am having here at the first index of this array. So what I will be doing is that I will be writing A. A is a variable in which I have stored out my array, right? A. Put the large brackets, and inside that I will be writing out the position, the index for which I am looking the number. So let's say I'm just looking for the first index. In that case, I simply wrote out 1 here. Now when I will be running out my program, I will be getting the output as 8. So just have a look here that I got my answer as 8. Yes. So why I am just getting here 8, that I have explained to you onto the OneNote, and again I am just repeating that basically what happens here is that if I have taken 9, 8, 7, 6, 5. Okay, so in that case 9 would be having the index as 0. So basically indexing starts from the number that is 0, right? So 9 would be having the number as 0, 8 would be having the index as 1, 7 then 2, 6 will be having the index as 3, and 5 would be having the index as 4. So procedure goes on like this. Basically whatever the n number of numbers you are going to enter, so it will be like based upon this thing on the indexing, right? Fine. This is actually how we just get out the answer. Okay, let me just give you one another example. Let me comment it out for a while here. Let's say, okay, let's say if I just write out print and put the, okay, just put out the brackets here, and inside the bracket, let's say I just wrote 3. Now basically at the third position, it's not the third value. Please make sure to remember this thing very carefully every time, that this 3 is the not value for which I want. I do not want it that at like third position, what is the value? I do not want that thing. I want the value at the third index. Okay, so third index is actually my 6th value. So at my index that is 3, I would be having the value which is 6. So let me go from here. Yes, here I am just getting the answer as 6, right? That is okay. This was about the positive indexing. Now, indexing is also of two types. I do not know that you have heard regarding this thing or do not, but indexing are also of two types. The first one is the positive indexing and the second one is the negative indexing. Okay. So, right now we had just discussed about the positive indexing. Let me take you to the negative indexing as well. So, right here, let me just take out, firstly, let me just erase this thing and this bracket as well. And let me just took out some another color. Let's see this one. Right here. So negative in okay. So let me first discuss with the positive as well. So positive goes from to the left towards the right direction. Okay. And negative goes from right towards the left direction. Okay. So this 5 will be having the index as -1, -2, -3, -4, -5. Okay, this is actually how the negative indexing goes, right? 5 will be having the index as -1, 6 will be having the index as -2, 7 will be having the index as -3, 8 will be having the index as -4, and 9 would be having the index as -5. So this is actually how the negative indexing works, and this is actually how the negative indexing goes on, right? Fine. Now, if I just write a -2, so now I'd be getting the number which is 6, right? Because at the -2 position, that is at -2 index, I am having the value that is 6, right? So I'll be getting the value here as 6, right? Let me just move on to the PyCharm IDE once again. Let me just write out the code to print out some negative index as well. Let me comment this out. And here I'll be using the print. In the bracket, it's a. Let's say I just want to write -3. Okay. And now I will just run out my program. So here I'm just getting the output as 7, right? I will be getting the output here as 7. So why 7? Because 5 would be having -1, 6 would be having -2, and 7 would be having -3, right? So this is actually how the negative indexing actually goes. So this was about the one dimension array. Now if I just want to talk about the 2D array, because we have the things in the 2D arrays as well, right? 2D array also have indexing. So let me declare a large bracket. So in 2D array, let's say if I just take a 2 cross 2 matrix, okay, I just take a 2 cross 2 matrix. So in that case, 0 0 0 1 1 0 1 1. Okay, so basically the index which I have, the number which I have entered here, that will be having an index as 0 0. This position will be having 0 1. This is 1 0. This is 1 1. Okay, so first row will be having the index as 0. Second one, the first letter will be 1. Then 2, then 3, then 4. It goes on like this. Basically, whatever the number of things you are having, it goes on like this only. Fine. Now, let's say I declare 2-dimensional array, that is 1 2 3 4. 1 2 3 4. Okay. Now, in this case, if I just write a of 0 comma 0, if I just write a of 0 comma 0, so I would be getting the number that is 1, because at 0 comma 0 position, I am having the number that is 1. Right? So this is actually how the 2-dimension array indexing works out. So let me just write out the program here for the 2D arrays as well. Right? Fine. So here we go. Okay. Let me just come to the next positions and let me just define an array. Let's say I will be taking a variable that is b is equal to, I will be writing np dot array into the bracket. I will be defining the 2-dimensional array, that is 1 comma 2, let's say comma, and that is let's say 3 comma 4. Okay. Now I would simply be printing here print, and in the bracket I will be printing here as b. Okay. Let's say first of all I want to find out that at a of 0 comma 0, that is 0 0 position, what is the number that we are having. Okay, that is not a, that is b. So if I just run out my program, so have a look that at my 0 0 position, what it is giving me. It is giving me that I am having the number as 1 at the 0 comma 0 position, right? So this is basically, this is my 0 comma 0 position, right? So in that case I am getting 1. Now if I just write here that I want the number for 1 comma 0, so this is 0 0, this is 0 1, and this 3 is 1 0, this 4 is 1 1. So if I write 1 0, so in that case I'll be getting the answer as 3. Let me change out to 1 0, and now let me just quickly run out once again. So this is basically, just have a look that here I got the answer that is 3, right? So this is actually how the indexing in 1D arrays and the indexing in 2D arrays actually work, right? This is the procedure which we follow for working out the indexing in the 1D arrays as well as the 2D arrays, right? And this is the concept of the indexing which is actually followed for, okay, even if it is taking arrays in, even basically if it's taking in strings or saying something like that, in that case also this is the only procedure which is followed, right? So I hope I just made this thing very, very clear to you that basically how to use out these arrays and basically how to do the indexing in the NumPy arrays, right? We had discussed that basically how we can do the indexing, how we can basically perform indexing in the NumPy arrays. Now, basically, we have one more concept which is similarly related to the indexing, which is basically you can say it's like a moreover for this for the indexing, and that is basically called as slicing. Okay, it is an upgraded version of the indexing, and this indexing is actually almost used in slicing as well. So let me explain you that what I just meant from the slicing word. It basically looks a little like another word, right? So slicing actually refers that let's say you have an array, a one-dimensional array, okay, that is containing 5 numbers. Now, if you want to extract some part of that array, you want to extract some part of the array. Let's say you are having 5 numbers in that array, you want to obtain only 3 numbers from that array. So in that case, basically, this is the place where we actually need the use of the concept which is called as slicing. So the slicing is one of the topics which is essentially used in the strings as well. Okay, this is a very important topic of the strings, but in even NumPy arrays also we have the slicing topic. So it is basically help us in obtaining a sub array from a array, right? Let me just go on to the one note and explain you this thing in a little detail, and let me tell you the syntax and all the things which we have here for the slicing topic. Okay, so basically what I will be just doing here is that okay, let me just define an array. Let's say that in array is basically having 9, 8, 7, 6 and 5. Let's say these 5 are the numbers that this array is having. Other than that, I told you that how to do indexing, right? Indexing is start from the 0th index and goes up to the nth index, whatever the number of you have written here. So for me, it would be starting from 0, 1, 2, 3 and 4. So at the 0th index, I'll be having the number that is 9. In the first index, I'll be having 8. And basically, it goes up to the 5, right? Now, if I want to do a slicing, let's say slicing is obtaining a sub array from an array. Let's say this is my array which is 98765. I want to obtain a small array from this, and let's say I want to obtain a small array, and that is 987. I want to obtain only this much of array from this whole array, right? So how will I be doing that thing? So in that case, basically we have a particular syntax that we apply. So let me tell you the syntax. So I will be putting the large brackets. Okay, first of all, large brackets are done. Between that large brackets, we just put one colon sign. Okay. After putting out this colon sign, what we actually do, at the left hand side of the colon, just please listen to me very, very carefully because it's a very important topic. If you are just listening to me carefully for the first time, then you will get it. Otherwise, you will be like almost every time you will be confused that what is the output, what shall be the output and all those things, right? So, besides the colon, that is on the left hand side colon, what you will be writing? You will be writing the number from which you want to start. So, that will be your start index. That basically from which particular index you want to start printing your array. Okay. And at the right hand side of the colon, what you will be writing? You will be writing the ending index. That is ending and that is index, right? So that at what particular index you want to stop printing your array, right? This is the whole idea behind this slicing which we actually have here. Okay, I would be letting you know the slicing a little bit more, but before that, let me just quickly move on to the PyCharm ID and let me start writing the code a little bit so that like you can just tally it from the previous one which you have even studied, right? I would be importing my NumPy library. So import NumPy as NP. That is done, right? After this, basically what do I have? I need to declare my array. So A is equal to, I'm writing np dot array. Okay. It's small bracket. First of all, I'll be taking one dimension array. I'll not be quickly like going on to a 2-dimension. I would simply take 1 dimension. So let's say I'll be taking the same numbers which I have taken as an example on the one note. So that is 98765, right? Come on to the next line. If I write here print A, I told you that what you need to do is that you need to first of all put a colon. So at the left hand side of the colon, you need to write out the starting index. That is, let's say starting index is 0. And on the right hand side of the colon, you need to write out the ending index, that at what particular point you want to end your array. So let's say I just wrote here as 2. Okay. And now I would run out my program here, run out my code which I have written. So just have a look at what I am just getting. I am getting 9 and 8. Okay, let me explain you how we are just getting this output. So when I mentioned that in the starting index I want the 0th. So in that case basically it started from a 0th index. So at 0 I was having the value as 9. So it started from that 9 value, that is basically particularly okay, right? On the ending index I mentioned that I want the ending index as 2. Now please always remember here that basically whenever we just put an ending index, so it always follows the same rule, which is n minus 1. Okay. Now this n minus rule is actually followed here. So for this 2, n is 2, right? So that is 2 minus 1, which is equal to 1. So it means your output, your array will only and only be printed till the first index, not till the second index. Make sure to remember this thing always, that if you have written any value here, let's say you have written 2. So your final output, you will be getting the array one index before the mentioned index which you have written into the ending index value. Okay, here you will be getting the output as 1. So not the output, basically basically the array which you are trying to print, that will be printed till the first index only. So from 0 and 1. So in that case you will be getting the output as 9, 8, which you are able to see here, that is 9, 8, right? Now let me give you one more case. First of all, let me just quickly erase out all of the things whichever I have just written here, like this and this one. Okay, just give me 1 second. Let me quickly erase out the things so that I can just write that again, right? So second thing comes here. Let's say I just take another example. Let's say I just wrote, I started from 1 and ended at 5. 1 till 5. So I have given my starting index as 1. So my at the first position, what value I am having? I am having the value as 8. So my output will start from 8. Ending index I have given 5. So it will follow the rule, that is n minus 1. So it would be 5 minus 1. That will result me as the answer as 4. So it will be printing me the output till 4. So 8, 7, 6 and 5. So I'll be getting the answer 8, 7, 6 and 5. Okay, let's quickly do it on the PyCharm ID and verify that is it giving the right answer or not. So I would just comment out this statement here and let me move on to the next line. Again, let me write here print A, and inside A what to add here. So I'll be putting 1 colon 5, right? This was the one which I had put here. Yes, 1 colon 5. Now I would run out my program here. So just have a look that here what I'm getting. I'm getting 8, 7, 6 and 5. And yes, this is the same output which I told you here on the one note, that we will be getting this output, that is 8, 7, 6 and 5. Right? So I hope I made this thing very clear to you, that basically how to give out the values here. Other than this, it's not finished up here. We have one more thing here that goes with the things, and that is another parameter which we have, which is step. Let me show you how to add on that step parameter. Just 1 second. Let me take out the pen right here. Okay, let me just quickly rub out the things which we have written, because I do not want to declare a new array. I just want to perform all of the functions into single array as well. Okay, so here we go. So as we had seen the starting and the ending index, with that same thing we have one more parameter, which is step parameter. Now actually what is the step parameter used for? So step parameter is actually used whenever you want to print array, like let's say it's the array which you want to print. Okay, now this array you want to print in a different way, like you want one element to be printed. After that you do not want the another element to be printed, then next element should be printed, then one element should be left, then another element should be printed. So that is basically simultaneously you just want everything to be printed, right? So in that case basically this step parameter is used. Let me show how we just use it. So first colon is for that starting index, this is for the ending. We again put one more colon here, and this is actually referring to my and this actually refers to my step parameter which we have here. This step parameter also follows the rule that is n minus 1. So if you are going to give the value here as 1, so for the case of, okay, let's say I just took one case that is 0 colon 5 comma colon 1. So this 1 is my step index, right? Now here also n minus 1 rule is followed. So 1 minus 1, that will be 0. So basically it will not give me any step. It will not leave any number after the numbers, and it will simply print me the whole array which I am having. Okay. Another thing, next thing comes that basically if I just give the value here as 2 instead of 1, if I just give out the value here as 2, then also it will following n minus 1. In that case 2 minus 1 will be 1, then it will be printing me 9. It will not be printing me 8, it will be printing me 7. It will not be printing me 6, it will be printing me 5. So it will printing me one element, after that it will be leaving one, another after it will print 1, then it will again leave 1, and the chain goes like this only, right? Let me go on to the PyCharm IDE and show you the example for that. Let's see if I just write out print here, and I just wrote A, and instead of that I just wrote 0 colon 5 comma colon 2. So in that case it follows n minus 1, so it will be giving me a gap between each and every number. So just have a look, that is the same output which is matching from the one note which I have told you. It is 975. So 8 is missing and 6 is missing because we have given here the step as 2. Okay. If I give the step as 1 here, simply give 1. And now if I just try to run it, then in this case basically it will be printing me the whole whole array which I am having here because n minus rule is followed. Another thing comes, let me just quickly comment out this statement, and one more thing actually comes is that if I simply use print, I put A and I do not put any starting index and the ending index. Okay, if I do not put anything in this case. So basically if I do not put the starting index, so it will automatically take the starting index as 0. Okay, and if I do not put the ending index, so it will automatically take the whole length of your array which you are having, and it will take up to the last index whatever you are having automatically. Okay, if I just put single colons and do not write anything here, so it will basically result with the whole array because it has automatically started from the 0th index and it will automatically finish up to the last index of the array which we are having, right? So I hope I just made this thing very clear to you, that how we can just perform the slicing on the arrays. Okay, this is actually how we just do the things. This is actually how the syntax goes on, and this is actually how you just give the indexing and the numbering to the array elements whichever you are having. Today we are going to see some arithmetic operations which you can basically perform on the NumPy arrays, right? So till now we had seen that how you can do indexing, how you can do slicing in the arrays. Now basically from now onwards I would be telling you that how you can just apply basic arithmetic operations. You know what are arithmetic operations, right? Addition, subtraction, multiplication, division, exponent, and all these things, right? So basically how you can perform all of these operations onto the arrays, this is the thing that we are going to discuss today, right? So let's begin up with the things for now, and here I am on my PyCharm ID and I'm going to start writing the code. Okay, basically I do not have any particular definition or particular write-up to let you know about the arithmetic operations. I would only write out the examples and show you that basically how to perform these operations on the NumPy arrays, right? So when I just again and again say NumPy array, so I want to make an array with the help of the NumPy library, right? So in that case, my very first need is that I need to import my library, right? Because I'm just going to use my NumPy library, so I need to import that right here. So the very first thing that I'm just going to do is that I'm going to import my NumPy library. So import NumPy as NP, right? This is the procedure how we actually import, right? We just import out the name of the library, and after that we just give it a short form. Let's say here I have given NP. Okay, actually why we always give NP, because it is a very common one which is actually used by everyone. Okay, that is the reason that at every place I simply give this name which is NP. Okay, let's come on to the next line. Okay, let me take a variable, let's say that is A, and one more thing, that basically we do not have any particular function name, so that is why I cannot use my help function here. Okay, because we do not have a particular function. It's basically only the operators that we are going to perform. Okay, So right here, I have taken a variable that is a. Okay, now into this variable, I'll be using my one of the functions that we have already studied here, and that is basically Arange, because I just want to give a particular range that display me the numbers from this point till this point. Okay, so let's say I just give you a 1 comma 5. Okay, and now basically I just want to print out this array. First of all, I want to see that basically what array is getting printed here. So for that case, I can simply write here print and then a, right? And I would just run out my program here. So basically in the output section, I'll be getting my output. So here we have 1, 2, 3, 4. So as I mentioned previously when I told about Arange, and right now I'm again repeating that the number which you have written here at the last, that will be excluded. Excluded means that will not be added here. So this is the reason that why I am getting the numbers between 1, 2, 3 and 4 only, because 5 will not be included here in the output. Okay, that is done. Right, I just printed it a. Now I just comment out this line. Let's say I want to add 2 to all the numbers into my array which I am having. Okay, let's say I just want to add 2. So basically in my array I was getting 1, 2, 3, 4, right? So I just want that each and every number should be incremented by 2, right? That basically in each and every number 2 should be added, right? So for that, what I'll be just doing is that I'll be writing out my print statement. Directly inside my print statement, I would write the variable for which I want this operation to be acted upon. So here that variable I am having as a, right? So I want this variable to be acted upon the array which I have stored in the variable that is a, right? So I would write a plus 2, and it is this much simple, right? A plus 2, that will basically increment all the numbers by 2 here as the output form. Now just have a look that previously I was getting the output as 1, 2, 3, 4, right? Now what I'm getting 3, 4, 5, 6. That is basically each and every number has been incremented by the number which is 2. So that I have simply written out here inside my print statement, right? Fine, let me just comment out this line for here as well. Let's move on to the next line. Now, basically, I'll be using out my print statement. So inside that print statement, let's say I want to multiply each and every number of my array by 6, let's say. Okay, I want to multiply each and every element of my array by 6. So simply I would write a multiplication 6 like this, and it's all over. I would just run out my program and be getting my desired output. So just have a look that my array was 1, 2, 3, 4, right? So in that case, if I just multiply it by 6, then I would be getting 6, 12, 18 and 24, right? So this is basically how I am getting the arithmetic operations, how I can perform the arithmetic operations actually. Now, let's say you want that whatever the numbers in your array are, you just want the power 2 of all those numbers. Let's say you just want to square all the numbers and just get the output of that, right? So for that, basically I can simply use out my print statement here, and for that I can simply write a and double star. This double star actually refers to the exponent, that is actually refers to the power, that how much power you want to give. So this is statement which I have actually written here. This is referring to a square. So a square means that whatever the numbers I will be having in a, that is my array, all of the numbers will be squared. So right, so currently I am having the numbers which is 1, 2, 3 and 4. So that will be squared, and just about look that what I am just getting, I am getting 1, 4, 9 and 16. So square of 1 is 1, square of 2 is 4, and for 3 it's 9, and for 4 it's 16, right? So in that case, I'm just getting all of the answers here, that is all of them are being squared, right? So these are the simple operations which you can perform on the one-dimensional array. Have a look that here I have only told about 1D array right now. Now let's move on to the 2D array and let's perform some operations on the 2D arrays, right? So I would just comment out this very first line as well, and let's move on here. Let's say I took a variable that is b. Okay, b is equal to np dot arrange. Okay, and let's say, okay, for now I will just not include arrays. Let me just take this example to the second of this one. Firstly, I would just give out some array. That is b is equal to np dot array, the bracket, and let's say the numbers which I'm just going to pass are 5, 6, 7, 8. Okay, let's say these are the numbers which I just passed. Now I'm just gonna not tell you that how you can print out this array, because this thing you know very carefully, and you just know absolutely that how to print out, because from the starting of this course I'm basically in each and every video I'm just telling you that if you just want to print your array, so how you will be doing that. So from now onwards I would not be repeating out that thing. Okay, simply let's say what I just want is that all the numbers, okay, all the numbers which I am having into my array, that are 5, 6, 7 and 8. I want all of these numbers to be, let's say, multiplied by 2. Okay, I want all the numbers to be multiplied by 2. So simply the procedure absolutely remains same. Only the difference is that when you just want to do it on one dimension array, so just declare a one dimensional array. When you do it on when you want to do it on the two dimensional array, so just declare out the two dimensional array. Other than that, in the print statement and for printing the output, none of the processes change actually. Okay, so in the print statement I would write b multiplication, let's say 2 I had said, right, b multiplication 2, and I would just run out my program here. So now just have a look that all of the numbers which I was having in my 2D array, here they are. Okay, just one second, right here. So all of the numbers which I was having in my 2D array, all of them have been multiplied by 2. So my numbers were 5, 6, 7 and 8. So when you just multiply them by 2, so I'm just getting 10, 12, 14 and 16, right? This is the multiplication, absolutely right answer. So this is basically how you can just perform the operations on 2D array as well. I would not tell you like addition, subtraction, all of the ones. I just gave you one example. Now rest is your work to try out all of the basically operators and act upon them. Okay. Now just one second, let me comment out this line. Now basically I have one more example for you. In that example basically I would be using my Arange function, as well as I would be taking an array. Okay, I would be telling you that how you can just both like use both of these together. So let's say basically I have taken a variable that is a. Okay, now into this variable I would simply write np dot arange. Okay, a is equal to np dot arange. And let's say I just give a value for the range as 1, 5. So 1, 2, 3, 4 will be printed, right? Other than that, I take a variable that is b. In that basically, I just gave np dot array. I just put the brackets, and inside that I just pass 5, 6, 7, 8. Right? Now basically, this is how you can use your arange functions as well, and you can declare your array as well. Right, now if I just want to perform the operation on this, I want to perform the operation on arange with the array, arange with the array, right? So what I would be just doing is that inside my print statement I would simply be writing a plus b. Let's say I just want to add both of these, right? Whatever the numbers are in my a variable, that is whatever the array I have stored in my variable, that is a, and whatever the array I have stored in my variable b, I just want the addition of both of those. So inside my print statement I simply wrote a plus b, and when I'm just going to run it, so basically here I'm just going to get the answer, that is 6, 8, 10, 12. Now how I am getting, because here I have written np.arange. So I have given a range as 1, 5. So the numbers that I would be having in my A array, that is 1, 2, 3, 4, right? This thing we have already seen above. Right now in this video itself we had just seen this thing, that if I'm just going to write 1, 5. So in that case basically what are the numbers that I would be getting inside this array, right? That is 1, 2, 3, 4. So now 1 will be added with 5, 2 will be added with 6, 3 would be added with 7, and 4 would be added at 12, right? And sorry, 4 would be added with 8. And with that only, I'm just getting the output, that is 6, 8, 10, 12, right? So I hope I just made this thing very, very clear to you, that how you can perform this, basically this addition. Now let's say I want to do multiplication. So in that case, I would be simply writing here print, and I'll be writing a multiplied by b. Okay, let me just comment out this line and let me print out. Okay, just one second. Let me comment this line and let me print out a and b as well, so that it's more clear to you. Print a, and then I would just write here as print b. Right, now let me just quickly run out here. Fine. Just have a look that basically my 5, okay, this 1, 2, 3, 4 is my first array, 5, 6, 7 is my second array. And the multiplication I'm just getting is 5, 12, 21 and 32. So 5 multiplied by 1 is 5. 6 multiplied by 2 is 12, 7 multiplied by 3 is 21, and 8 multiplied by 4 is 32. Right? So this is basically how I am getting here the multiplication of all the numbers which I have taken. Right? So basically, I hope I just made this thing very clear to you that how you can perform the basic arithmetic operations on the 1D array as well as on the 2D arrays, right? So this is actually how we can just perform basic arithmetic operations. You can just apply some divide here or whatever you just wish you can just apply. And you can just even take two two-dimensional array and apply the same functions on them as well. Basically, we had finished up with the arithmetic operators in the previous videos, right? Now we'll be seeing up the reshape and resize. These are the two very important functions in the Numpy arrays when we just talk about the Numpy arrays, right? So these are the two functions which plays a vital role in the arrays, right? So we'll be discussing about the reshape and the resize functions for now. So before diving into the code, let me just give you an idea that what is the use of reshape and what is the use of the resize function. After that, we'll move towards the coding, right? So here it is written that reshape function gives a new shape to an array without changing its data. So basically, as from the name only, you will be basically getting an idea that what's the use of this reshape function, right? So reshape means to giving something a new shape, right? So reshape function actually gives a new shape to an array without changing its data. So whatever the data you are having inside the array, okay, let's say you have a 2D array and you want to change its shape. So you can change its shape, but its data will not actually be affected, right? This is the whole idea for the reshape function. Then come to the resize function. So what's the use of the resize function? So it actually returns as a new array with a specified shape. Okay. Basically, when you have specified a particular shape. Okay, let's say we just say that, okay, I just want this particular size of my array. So it will return you a new array with that specified particular shape. Right? So these are the idea regarding the reshape and the resize functions. And after that, when you are just gonna like write out the code for both of these functions, then you'll be getting more clear that what's the use of these and how we just use them in the Numpy arrays, right? So without wasting time, let's code out the things and say that basically what is the how we just write out the reshape and resize functions, what's the use and all those things. Right, so as I said that these are the functions which we will be acting upon the Numpy library. So the very first procedure I'll be importing out my Numpy library. So import that is Numpy as NP. Right, I would be using out my help function as well. Okay, so help and inside this I'll be using np dot and that is reshape. Okay, help is equal help and in bracket np dot reshape. So after running out, just have a look that I just got the details about the reshape function. So let me just go above and show you. Fine. So these are the parameters which you have in the reshape function. The first parameter is A, second is the new shape, and third is the order that is equal to C. Now basically here order is equal to C. What does this actually mean? So that I'll be letting you know in a little while. Okay, basically there are 4 types of orders which you can apply. So I would be telling you in detail about all those 4 in a little while. Okay. So these are the parameters which you can just add on here. And other than that, okay, let me come down and see that basically what does it actually returns. So it actually returns a ND array and this will be a new view of object if possible. Otherwise, it will be a copy. Okay. That is fine with me. And other than that, basically, there are some examples and all these things which you can have a look on your own. Right. So I will be moving up with the code for now for the reshape function. Okay, let's come down and let me just give out a variable and define a array. So I would not be just simply taking out that array function. I would be using my Arange function. Okay, np.arange and in the bracket I have written here as 10. Fine. I would be simply using out my print statement to print out this array. I just want to check that what are the things that are coming into this array, right? So here we have it basically started from the automatically started from the 0th index. Okay, because I haven't mentioned any particular index value, that is the reason it automatically started from the 0th index, right? After that I have 0 1 2 3 4 5 up to 9 because 10 is excluded. 10 will not be included because we have just put that as an ending value, right? Okay, just one second, let me come above right here. Now I'll be using out my reshape function. First of all, let's say I want to check out that what is the shape. So for the shape, we had already seen out the functions, right? I had already told you that what function will you be using for the shape. I told you this thing in the attributes of array, right? That how we can just check out the shape of an array if you want to, right? So a dot shape, and basically it is telling me that it has 10 rows, but it basically has no columns, right? Because it is a 1D array, right? So now I want to reshape this out. I want to reshape this out. So how will I be doing that? For that, I'll be taking a new variable. Let's say that variable is b. Okay, so b is equal to, I'll be using np dot my reshape function. Okay, np dot reshape. I would be putting out the bracket here. Then I'll be writing the name for the variable in which I have stored my array on which I want to apply my reshape function. So for me, it is a actually, right? I would put a comma. Now after putting that comma, I put one brackets here. And inside that bracket, I would write that in which one, like how you just want to reshape that array. Okay. So I have written here 5 comma 2. So I want to reshape my array in 5 comma 2. That is what I just want is that 5 rows should be there, and other than that there should be 2 columns, right? And I would simply print out B here. Now just as soon as I run out my program, now have a look here that how did I just got my array. So my array has been turned into, now it is basically having 5 rows, right? It is having 5 rows and it is having 2 columns, correct? Why I am getting like this? Because I have mentioned there, just one second. Here, this is the place. I have mentioned here that I want 5 comma 2. That is, I want 5 rows and 2 columns. Previously, my array was having a shape as 10. Okay, my array was having a shape as 10 comma. Now, if I would be running that, I would be checking that what is the shape of my array now. So, it will be giving me that shape is 5 comma 2. Let me show you how. Let me just go above and let me just print here b dot shape, b dot shape. And now if I just run out my program once again, so basically have a look, I'll be just going downwards here and just have a look that basically here I'm just getting that it is having a shape as 5 comma 2, right? So this is basically how we just check out, how we just change out the shape of any array which you are having, right? So I had changed out the shape for this one. Now I just comment out this b and all those things right here. Just let me comment out this as well. Now let's say I just want to okay, I take c as another variable for me. In that basically I'd be simply using that reshape function only, and I would be reshaping that a as well. So a comma I'd be writing here 5 comma 2. Okay. Now I was discussing about the order, right? That I was discussing about the order. So let me just write here. Okay, just one second. Let me just write out here as f, and let me show you that what I just meant from the orders, right? So one note right here. So when we just do not put any let's say order, okay, let's say I haven't put any particular order, so it will automatically take that order as C, and it actually means that it will reshape my array with the row wise. Okay, it will reshape my array row wise. Next I have F, that is for column wise. Let's say I want to reshape my array column wise, so in that case I'd be using out this F order. Okay, A is for fortran wise and K occurs in memory. For now leave this A and K, for now just focus upon C and F. So C is basically for my row wise and F is for my column wise. Okay, so let me now run it here. Let's run it now. Okay, oh, I'm sorry, I haven't printed C here. Let me just quickly print and then C here. And let me just run out my program for now. Right here, so just have a look at what difference actually I am getting. I am getting here the difference as, now I am getting 1, 2, 3, 4 like this. And after that on the other column, I am getting 5, 6, 7, 8, 9. Previously, when I have not applied, so in that case, what I was getting, let me just quickly print out the B as well, right here. And let me quickly run out. Just have a look. Previously, I was getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 like this. And when I applied the basically the order, that is F, that is my column wise right here. So this is my column wise, right? When I just applied that, so after that, now have a look at what output I am getting. I am getting 0, 1, 2, 3, 4 in one single line. And then on the other line, I am getting 5, 6, 7, 8, 9, right? So this is basically how we just use out the reshape function, and this is actually what's the like orders which we have here in the functions, in the different functions, okay? Right. So I would just now be commenting all of these things. So I'll be moving towards the next thing, that is my resize function. Till now we have seen the reshape, right? Now I'll be moving towards the resize one. So first of all, I'll be using that help and np dot resize, and I will be running it here. Fine. So basically, it gave me the idea for my resize function, right? So it is telling me that you have two parameters here. The first parameter is a, and the second parameter is new underscore shape. And basically, what does it returns? It returns a new array with the specified shape, right? Other than that, what are these parameters? So a is the array like, that is the array which has to be resized, name of that array, and the new shape, okay, which you want to apply. So what does it actually, okay, here we have the cursor. So what does it actually returns us? Okay, I'm sorry. So what does it actually returns us? So it actually returns us an ND array. The new array is formed from the data in the old array repeated if necessary to fill out the required number of elements, okay? Fine. And other things you can just check out on your own, the examples and all those things, right? I'm just not going to show you that thing right now. Right here. Okay, let me just take a variable, let's say that is a. I will be simply applying np dot Arange. Okay, and in the bracket, let's say I just wrote 5. Now, by the time you must be having a clear idea that if I just wrote np dot Arange, then what array will I be getting? So you'll be getting an array as 0, 1, 2, 3, 4, and 5 will not be included because that is the ending value which I have given, right? And basically here I have given here basically I haven't given any starting value, so it will automatically start from 0, right? Come down. Here I'll be using the resize function. So print np dot resize, np dot that is resize. Okay, in the bracket I'll be writing the variable which I want to resize, that is a. Okay, now what I just want to resize, that is 2, 3. I want this to be appearing in the 2 rows and 3 columns. So just have a look here that I am getting 2 rows and 3 columns, 0, 1, 2, 3, 4, 0. Now basically I was only having 5 values, but in my the shape which I have given, that is consisting of 6 values, right? 3 multiplied by 2, that is 6. So whichever the place would be empty, in that place automatically the 0 will come. So that is the reason that here the 0 is automatically coming, because this place is empty and we do not have any particular number to include here, right? In this np.arange, instead of 5, if I just make it 6, and now if I just run out my program once again, then basically it would be giving me the value, instead of 0 it will be giving me 5, because 6 will be excluded and I will be printing till 5, right? So it is giving me 0, 1, 2, 3, 4, 5. Right, so I hope that you have got a clear and a fair idea that how does this reshape and resize function actually works in the numpy arrays, how to apply them, what are the things that we do, and why we just apply them in the arrays, right? So basically today we are going to discuss about the flatten function. This is one of another functions which we have in the numpy library. So flatten return a copy of the array collapsed into one dimension. This is the use of the flatten function which we have here, that it basically returns me a copy of the array collapsed into one dimension, right? This is the use of this flatten function. Fine. Now, basically, this must not be very much clear to you that what actually this flatten function do, why we just use it. So, this is a kind of a hint, and after that, I'll be writing out the quotes, and then in that, basically, you will be getting in a clear and a fair idea that what does this flatten function actually do, right? So, I would be starting up here, and the very first thing that I would be doing is that I would be importing out my numpy library. So, import numpy as NP, right? Import numpy as NP. The very first thing that I have done. Now, in the very beginning, when I just started with the Arange function, so in that basically I told you that basically we have a function which is help, right? And that help function is used to tell us the syntax, used to tell us the examples and all those things it basically tells us. But I even mentioned one more thing at that time, that basically there are some functions on which this help does not work. So flatten is one of them, one of that function on which this help function actually does not work. So if you're just going to use help and in bracket you are going to write np.flatten, so in that case basically it will show you some kind of error, right? So this flatten function is not used, this help function is not used with the flatten function, right? So I'll be not be using that and I would simply be taking a as my variables, right? So a is equal to, I would be making one of my array here. Okay, let me take a 2D array first of all. Let's say my array is 5, 6, comma, and it is 7, 8. Okay, single comma right here. Okay, just 1 second. Right here. Now, I have just made out my array. I just want to print it, so I'll be writing print, and in the bracket, I'll be writing here as a, right? I will just run it for a while. And this is my two-dimensional array, which is having the shape as 2 cross 2, right? That is 2 rows and 2 columns, right? I would be closing it this thing here. Now, I would be using out my flatten function. So print bracket a dot and that is flatten, flatten, right? And I would just put out the bracket here. Now, when I would just run out this program here for a while, so now have a look that basically what has been done. So my array was my 2 dimensions array, right? So that 2D array has been converted into 1D array. Just have a look that this was the previous my real array which I have printed here, right? And as soon as I just use out my flatten function, so it has basically this 2-dimensional array has been changed into 1-dimensional array. So the definition was that it returns a copy of the array collapsed into 1 dimension, right? So if you are taking a 2-dimension array and you want to convert that 2-dimension array into 1 dimension, so in that case basically you can just use out this flatten function, right? So it is basically returning me a copy of the array which is collapsed into 1 dimension, right? So that is done. Let me just come down here. And basically the use of this flatten function is usually this thing only, that it is used to convert a 2D array into a 1D array. Other than that, basically we have some more things here. I even have that order which I have told you in the previous video, right? You remember that in the previous video I have told you 4 orders, right? C, F, A and K. So C was for my row wise and F was for my column wise. We're just focusing upon these two for a while, right? So inside my print statement, I will be using a dot flatten, right? Inside the bracket, let's say I just want it to be column wise. Okay, so in that case, basically what I will be doing is that I'll be writing order. Order is equal to, and I'm writing here as F. Okay. And now just let me quickly run out my program. Now basically have a look that according to the column wise, my middle values which were 5, 6 and 7, they have been interchanged and they are 7 and 6 right here, right? So this is basically how this order actually works. Now you can just apply, okay, by default the order is C always, that is my row wise. But if you just want to make it to the column wise, so you can simply, in the place of the order, you can simply apply here F, that is basically used for my row, that is used for my column wise. Okay, that is done. Let me just comment out all of these things, all these 4. Let me just comment it out right here. Now, basically, I'll be using out B, my another array which I'm just gonna make, right? B is equal to np dot array, right? In the bracket, I would be putting out let's say 1, 2, 3, right? Let's say my 3D is array. 1, 2, 3, 4, 5, 6, and then I have 7, 8, 9. Right? This is the array which I have, let's say, declared here. If I just want to print it out, so writing print and then breathe. So basically this array will be of my 3 cross 3, right? So here I just got my 3 cross 3 array here. Now, if I apply the flatten function onto this, okay, if I just write print and then I just write b dot flatten and I put on the brackets here. Now just have a look that basically what will happen, my all the that 3 cross 3 array has been converted into one single 1D array. and all the numbers have come into one single line here. Just have a look, right? That all of these numbers have came into one single line. So basically my array has been converted into 1D array, right? So here I was having 3 cross 3. So that 3 cross 3 has been converted into one dimensional array, and that is because of my flatten function. Now if I just change out the order as well, if I just write print and I just write b dot flatten, and into the bracket I just write order is equal to f, right? And now if I just run out my program here, now just have the look that all of the values, many of the values have been actually interchanged, because it has been sorted, it has been made according to the column wise, not according to the row wise. Okay, according to the row wise it was previously, which is 1 2 3 4 5 6 7 8 9. Now if it is want to convert it into column wise, so this column wise it actually looks like this, right? So this is basically how we just check out, how we just say that your order has actually changed. So when I just do not write any order, so in that case basically C is the by default order. C is basically my row wise, and if I just want to change, I just write F, that is basically my column wise, right? So this is the actual use of the flatten function, which I told you that it will basically return you a copy of the array collapse into one dimension. So any dimension array you just write here, it will convert that any dimension array into 1D array, and this is the actual use of flatten function, right? So I just hope I made this thing very clear to you, that how we just use out the flatten function and what is the use of this flatten function in the NumPy arrays. Right, to discuss about the ravel function, that is ravel. Ravel is another function which we have in the NumPy arrays. We just apply it in the NumPy arrays. Now, what is the use of applying this ravel function in NumPy arrays? Like basically why we just do that thing. So, if we just want to change a two-dimensional array or a multi-dimensional array into a continuous flattened array, then in that case basically we just apply the ravel function, right? We had discussed about the flattened function, that is a flattened function in the previous video, right? So in that basically what was happening, that 2D array was converting into 1D array, right? That was the idea which was happening in the flatten function. So it's just a kind of similar function to the flatten as well. So in ravel function is used to change a two-dimensional array or a multi-dimensional array. Now basically here we have 2D array or a multi-dimensional array into a contiguous flattened array. This is the whole idea behind this ravel function. Now basically you will be getting a more clear idea when we just start writing out the functions, right? When you start writing out the code, in that case basically you'll be getting the more clear idea that what is this ravel function actually used for. So let's begin up with the coding for now, and the very first thing I'm just going to do is that I'm going to import out my NumPy library, because this function is a part of my NumPy library. Okay, so I've just imported out my NumPy library and given it a short form as NP. Right, that is done. Now, what I would be just doing is that here, let me check out that this ravel function will actually work for, this help will actually work for the ravel function or not. That is RAVE, like this. And now let me just quickly run out this program here. So basically this ravel function, with the help of this help, we just got the idea to see out the ravel function. And okay, just 1 second, let me take it to here, right here. So basically what's the use of this, and firstly what is the parameters? The parameters are A is basically your array, basically the variable that will be containing your array, and other than that basically we have the order as well. Okay, we have the order, and basically the order is C, right? Basically C, that is the by default order, which is actually referring to my row wise, which actually makes my array into a way that is row wise. Okay, other than that basically these are the parameters which you can just have a look on your own, and what it returns, it basically returns you an array. Y is an array of the same subtype as A with shape. Okay, so this is the whole idea regarding this ravel function. Rest of the things you can just have a look on your own. I'm just not going to tell you that thing here. Fine. Let me comment out this here. Let's begin now with the example for the ravel function. Now what I will be doing is that, let me take a variable, let's say A. Okay, and I just want to make an array, that is A is equal to np dot array, right? I would just put out the bracket, and let me just declare an array. Let's say my array is 2 comma 3 comma and it's let's say 4 comma 5. Right, this is a 2D array which I have declared here. Fine, I have just made it. Other than that, I would just come on to the next line. I would just simply try to firstly print out my array, that is which I have just mentioned here. So I will be writing print A and it will basically be giving me the array that is 2, 3, 4 and 5. That is a 2 cross 2 array, 2D array which I have just made here. Right, now basically rather than this, what I would be just doing is that I would be checking out my ravel function. So with the help of my print statement, I will be writing print here, and with that statement basically what it is doing is that I will be writing np dot ravel. That is my function name, and into the bracket I'll be writing out the variable on which I want to perform this. So I want to perform it on the variable that is a. Right, and now I would just run my program here. So now just have a look that my 2D array has been converted into 1D array as well. Right, now so basically what was written above, it was that it is used to change a 2D, two-dimensional array or a multi-dimensional array into a contiguous flattened array. So flattened array is actually referring to the flatten function which we have, and that was actually used for converting my 2D array into 1D array, right? This was the use of that particular function. So it is also doing the same for me. Let's say I want to change out the order. So in that case, I'll be writing out that print here np dot ravel. Okay, print np dot ravel, and I would just put out the brackets a comma. Okay, a is the variable on which I want to apply the ravel function, right? So in that case, I just simply put on that a here, right? So that I have written. Other than this, I would be writing comma, and here be adding the order. Okay, that basically what is the order which I just want to apply here. So order I want to apply here as f, and that f is basically referring to my column wise. And now if I just run it again here, so yes, now just have a look that the between values, the values which were in the middle, that were 3 and 4, that have been interchanged to 4 and 3, and that is actually because of the ravel function which we are using. Right, so this is the actually use of the ravel function. Other than this, let me just firstly comment out all of these things which I have just written out here. Right here, comment. Now I'll be taking one another example, and in that case I'll be taking a 3 cross 3 array. Okay, so let's say I took the variable that is b, and that is np dot array. That is basically used for making out my array, right? I would put the bracket and these large brackets. Now inside these brackets I'll be putting out the 3 ones because I'm just like making a 3 cross 3 array. Okay, so I want to put out some values. Let's say my values are writing 9, 8, 7, and that is again comma 6, that is 6, 5, 4, again a comma, and that is okay, first and 3, 2, 1. Right? These are the values which I had just put on and made my 3 cross 3 array. So if I just want to check out my 3 cross 3 array, I will be simply printing out here, and I will be writing here print, and in the bracket I will be writing here as b, and I would be running it here. Right, so that I have done, and so because of that only I just got the answer here, and that is 97654 That is my 3 cross 3 array. Now if I want to apply my ravel function into this, so I would writing my print, then I'll be adding np dot ravel, and into the bracket I'll be writing out the name of the variable on which I want to apply out this ravel function. Let's say in my case it's b, right? So I just written that b here, and now I would be running my program. So just have a look that my 3 cross 3 array which I have declared has been changed into one single dimension array, right? And I am getting all of the values which are 987654321 into one single array, right? And I'm just getting all of these things here. So this is actually how the ravel function actually works. Other than that, I would just want to apply and change out the order as well. So I'll be writing print np dot ravel. I would put the brackets here. Then the name for my variable on which I want to act is b. It's single b, comma, and after that I'll be adding here order is equal to, that is capital F, right? Okay, instead of REVEL, it's RAVEL, that is ravel, right? And now I would just like to run out my program here. So instead of that, basically now have a look. That firstly, when I just did not apply my order, that is if, I was simply getting the correct answer, that is 987654321, and that was an ordered one, right? Because in that I haven't mentioned my default parameter, my order parameter. So in order, basically by default the value was C, that is the like name was C, order of that was C actually, and that is actually referring to my row wise. So everything was sorted with the row wise. Now when I changed my order to F, that is basically my column wise. So in that case, now I am getting the result according to the column wise changement, right? So in that case, the values which are in the middle, they have been like basically gone here and there because of the order which I have mentioned, and which is the column wise, right? So I hope that you have got a clear and a fair idea that what is the ravel function. So ravel functions are used to change a two-dimensional array or a multi-dimensional array into a contiguous flattened array, right? This is the actually use of the ravel function which we apply. So flatten and ravel, these two are the functions which are actually similar to each other, right? The functioning of both of these are quite similar to each other, right? So basically, I hope that I have made this thing very clear to you about the ravel function, how you use it, what's the work of this, and all those things. Seeing out the flatten and the ravel functions, now we'll be seeing out one very interesting function in the NumPy arrays, and that is basically the transpose function, right? Now we'll be seeing that how does this transpose function actually works, right? What is the use of this transpose function in the arrays, and what's like basically how it actually works, right? So before that, let me just let you know that what is actually the work of the transpose function. So basically you have just in your school times you have learned about the matrices, right? You have learned about the matrices and determinants. So in that case, basically we were having a term, and that was transpose itself, right? That was basically interchanging the values of the row and the columns, right? Now same use is here itself, that the transpose function changes the row elements into the column and the column elements into the row. If I just say it in a short way, so it just say that a transpose function actually helps us to interchange the values of the row and the columns, right? So very first of all, this is the whole idea for the transpose function which we have in the NumPy arrays. Now we just use this function for interchanging the values of the rows into columns and the columns into rows, right? This is the whole idea which we just apply for using out the transpose function. Now what I'll be just doing is that I'll be writing out the code and letting you know with that itself that how to use this transpose function, right? So let's start using and writing here. So basically in this code which I'm just going to write, I'm just going to use some previous functions as well, right? I'm just going to use some previous functions as well which we have already learned. So I would just request you, if you are basically, if you have forgotten the functions which we have not, which we have basically seen previously, so just again have a look over that functions, and now just have a look over this video, okay? So let's get started with the things for here. So what I'm just doing is that I'll be first of all importing out my NumPy library. So in that case, I'll be writing import NumPy as NP. This is the thing which I have done, right? And I would be using out my help function first of all to check out my transpose. Okay, so help and then here transpose. np.transpose, and now I'll run it. So basically it just gave me many things about this transpose function. So basically the parameters are a and the x. These are the two parameters which we have here, and what it does, okay, let me take this to the upper side. Fine, it's okay. Now basically what it does, it actually reverse or permute the access of an array, returns the modified array. I just mentioned that it basically changes the value of rows into columns and the row and the values of columns into the rows. So it's the work of the transpose function actually. So here it is defined about the parameters. You can just have a look over that on your own, and what it returns, it basically returns as an empty array, right? So and the examples are also given. You can just have a look of all of these things on your own. Let me comment out this line here. Fine. Let's move here. And basically here what I'll be just doing is that I'll be writing out the code. So let me take a variable that is a, okay? And first of all, I'll be using out my Arange function. In a is equal to np.arange, and into that let's say I just wrote 1 comma 11. So basically it will be giving me all the values between 1 to 10, and 11 would be excluded because this is the ending value which we have given, right? That is done. After this, with this Arange function only, let's say I just want to use another function also. Let's say I just want to reshape this array. It would be a one-dimensional array, right? Because I have simply mentioned my Arange function here. So it will be coming in my one-dimensional array. Let's say I just want to reshape this. So I would put a dot here, and instead of again and again creating many variables and using it on the separate lines, what I would just do is that on this particular line itself, I would put a dot, and basically here I'll be using out my reshape function. So inside the bracket I'll be mentioning the number of rows and number of columns which I basically want for this to appear. Okay. Now come on to the next line. Basically now if I just want to print out my array, so print A, and in that case I'll be getting my array which will be having 5 rows and 2 columns. So have a look that here I am getting 5 rows and 2 columns, and with that I am getting the numbers between 1 to 10. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From 1 up to 10 I'm just getting all of the numbers, right? That is absolutely fine. Now if I check out the, first of all I would check out the shape for this, okay, because I would just write here print, and for that I would write a dot shape. We had discussed how to check out the shape in the attributes of array, right? Sorry, attributes, yeah, attributes of array. So basically the shape which I'm just getting here is 5, 2, right? That is the shape which we have mentioned here, that I wanted to be reshaped into 5, 2. So that is actually coming. Now the thing that comes is that if I just use out my transpose function, so I'll be using out my print statement here. I'll be writing np, that is the name for my numpy library. Okay, np dot, and here I'll be using transpose, np dot transpose. Okay, and into the bracket I'll be writing out the name of the variable on which I want to apply out this transpose function. So let's say that is a for me. Okay, I'll put the dot, and here I'll be applying the shape function. I even want to transpose and check out the shape as well. Okay, so right here, that now have a look that basically what output I'm getting. So the shape is basically 2, 5. So this means that the shape of my array now has been reverted, that is 2, 5. Okay, firstly let me just display the array. Let me check out the array. So np.transpose A, and I would just run it now. Right here. So just have a look that previously when I haven't used my transpose function, so I was getting 5 rows and 2 columns. Afterwards, when I have applied my transpose function, so my values per row have been, so the values which I was having the rows, they have come into columns, and the columns value have been come into rows. So because of that, now I am getting here 2 rows and 5 columns. So the values have actually interchanged. So the number of columns that I was having, that have been interchanged with the number of rows which we are having, right? Now if I check out the shape, okay, so if I just put on a dot here and just write out the shape and now run my program, so now it will be giving me that now your shape is 2, 5. Previously it was 5, 2, right? Previously it was just one second. Previously it was 5, 2, because I haven't used my transpose function previously. But as soon as I applied my transpose function, so my values, like the values for the rows and columns have been interchanged, and the shape has also changed, and that is now 2, 5, right? So this is basically how we just use out the transpose function. Let's take some another examples as well. Okay, now what I'll be doing is that I'll be writing here, let's say b is another variable, and I would be applying np.arange. Okay, np.arange, and into the bracket, let's say I just wrote 1, 25. Okay, dot reshape. Now basically we have, I just want to reshape it. Now instead of 2-dimensional array, let's say I just wanted to reshape into 3-dimensional array, that is x, y and z, 3D arrays, right? I just want to like change it to 3. So in that case I'll be giving, let's say 2, 3, 4. This is basically the 3-dimensional array, how I can just reshape it. Now here we'll be getting to know how to reshape the 3D basically a 1D array into a 3D array as well, and I will print here as b. Right, let me just run out my program and explain you what is meant from 2, 3 and 4 right here. So this 2 is actually referring that I want 2 arrays. Okay, this 3 is actually referring to the number of rows which I have, and this 4 is actually referring to the number of columns I have. Okay, so 2 is my number of arrays, 3 is my number of columns, and 4 is my number of, 3 is my number of rows and 4 is my number of columns. Right, just have, again I'm just repeating, please write this down on your pen and paper, whatever you are just using. 2 is the number of arrays, 3 is the number of rows, and 4 is the number of columns, right? Now basically these are the two arrays which I am just getting, and they are having the numbers between 1 to 24. So I've just written out the range as 1 to 25. So 25 will be excluded, it will not be included, right? Now, if I apply out the shape, so okay, let me check out the shape. So that would be print, and in that b dot shape, right? And I would just run out once again this thing. So the shape which I'm just getting is 2, 3, 4, which is the required shape which I have mentioned here. Now, if I apply out my transpose function, so if I just write out here print, okay, and I just wrote print, and that is np dot transpose, and into the bracket I just wrote the variable which I want to transpose, so that is b, right? And now I run it. Again, have a look that the values have been interchanged. Now just have a look what I am just getting. I am getting 4 arrays, okay. Previously, I was having 4 columns, but now it has been interchanged to 4 arrays. Other than that, I am getting 3 rows. 3 rows actually remain the same, which is actually in the middle, right? And I am getting 2 columns, right? So previously I was getting 2 arrays, but now I am getting 2 columns. So number of arrays and the number of columns have been interchanged with each other. Okay, so this is the whole idea which is actually followed here. Now, if I just try to run out the shape for the transpose one, if I just check out the shape, so if I just write print and the bracket np dot transpose, in the bracket it's b dot shape. Okay, and now if I just try to run this here, now I would be getting the answer. The shape for my transposed array is 4, 3, 2. As I mentioned that the values for the number of array and number of columns have been interchanged with each other. So previously I was having number of arrays as 2, but now I am having the number of columns as 2, right? So this is basically how we just use out this thing. Now, if I want to apply my transpose function in one dimensional array, we had seen in 2D array, we had seen in 3D array. Now, if I want to apply in 1D array, so I would just write a is equal to np dot arange, and in bracket let's say 1, 10. Okay, I would simply print out my a. Okay, I would just 1 second, single I here I would add right here, and now I would just try to run my program. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that is okay. Now what I would be doing is that I would be applying out my transpose function. So that would be print, and in the bracket it would be np dot transpose, and into the bracket it would be a. Okay, now when I just try to run this program, so basically here I would not be getting any changement in the array which I have made. Why I would not be getting? Because here we are only having one row. We do not have any number of columns or something like that, right? I am only I'm basically having one single row, right? So because of that only, here none of the changes will be acted upon the 1D array. So if you just want to transpose and apply this transpose function on some arrays, so for that you need to declare the 2D arrays or the 3D arrays. So in a 1D array you will not be able to see the changes for the transpose function, right? So I hope I just made this thing very clear to you that how does this transpose function actually works, what are the things you can apply, where you can apply transpose function, where you cannot apply. So let me give you a revision that transpose function actually changes the row elements into the column elements and the column elements into the row elements. So in short, it means it is the interchange of the values of rows and columns, right? So I hope this must be very much clear to you regarding the transpose function. Today we are going to discuss about another function that is swapaxes. Right now, this is a function in the Numpy library, in the Numpy, basically Numpy array, which help us to interchange two x's of an array. Okay, this function which we are going to deal with, that is swapaxes, it basically helps us to interchange the two x's of an array. Now, basically, okay, I have one question for you that basically in some of your mind it would be coming that uh, we were interchanging the x's. Right, we would interchange. What are x's? X's are your 0 and 1. That is the row and column. Right, this is actually which your x's is. So we were interchanging the x's in the transpose function as well. What was the use of the transpose function which we have seen? So transpose was actually interchanging the rows and columns, right? And this axis function swap axis is also doing the same thing. Basically, it is interchanging the two x's of an array. So if I just say directly, so it is changing the rows and columns. Now, basically, what's the difference between the swap axis and what's the difference between the transpose function? Why we just use transpose function and why we even use swap axis as well? Right, so the answer for this question you will be getting at the last of this video. Okay, so I'll be starting here firstly with the swap axis, that basically what's the use of swap axis, how we just do it, how we just write out the codes. After that I'll be telling you the difference between the transpose and the swap axis. Right, so swap axis is a function which interchanges the two x's of an array. Let's do it with the code. So firstly I'll be importing out my numpy library. So import numpy as np, the very first step that I have done here. I would be using out my help function. So help np dot swap axis. This is the name for my function, help np dot swap axis, and I would just run it out here. So basically, I just got all the details about my swap axis function which we have. So basically, we have three parameters, that is a, x1 and x2, right? Other than that, what's the use? So it is basically used for interchange two x's of an array, right? That is the whole fine idea. Now, what are the parameters? The parameters are a, x1 and x2. So x1 is the first axis and x2 is the second axis. That are your row and columns, right? So these are the things which you can just read on your own. Rest of the things are given here, and you can just even check out the examples as well. Right, I would just comment out this help one for a now and come on to the next line. Basically, I would be taking a variable. Let's say that variable is a. Okay, I would be defining out my array. Let's say np dot array, and I'll be putting out the brackets, and let's say I would define a 2D array. 1 comma 2 comma, that is 3 comma 4. Okay, let's say this is the array, and let's make it to 11. Okay, let me make it to 11, 12, 13 and 14. Since a long time we are simply taking 1, 2, 3 and 4. Okay, fine. So that is done. Now I want to print this array. So in that, simply I can just write print a. That will basically print me my 2D array which I just have written here. That is 11, 12, 13 and 14. This is absolutely okay. Now if I want to swap up the axes, I want to basically swap the x's which we have here, right? So I would be writing here print. Okay, put the bracket. I would be using my swap axis function. So print np dot swap axis. Okay, into the bracket I'll be writing a variable for which I want to swap. So I have stored my array that I have declared here, 11, 12, 13 and 14. This array I have stored in the variable which is a. So I'll be writing that a variable inside the brackets, right? So a comma, that is now 0 comma 1. So I just wrote here 0 comma 1, and now when I would run out my program, so have a look. Just have a look very carefully that previously I was getting 11, 12, 13, 14. Now what I am getting? I am getting 11, 13, 12 and 14. So basically the values have been interchanged here, right? So the values which I was having here have been interchanged. So the value which I was having into my column, that has come into my row, and the value for my row has gone into the another column, right? So this is the whole idea which I was having here. Right, basically now another thing, if I just write it to 1 comma 0, if I just write it to 1 comma 0, so when I would just write 1 comma 0 and now run out my program, basically then also you are able to see out the change here, that is 11, 13, 12 and 14, right? This is basically how the swap axis function works, right? This is actually how the swap axis function works. Now I would be just commenting out this thing here for a while, and let's move on to the next thing which we have here. Now let's say I just took out a variable that is b, and in that I just wrote np dot array. Okay, I just put the brackets, and inside that I just declared my array. Let's say 1, 2 and 3. 1, 2, 3. Fine. Come on to the next line. I would simply print out the b. That is my variable. Okay, that is my variable in which I have stored my array. So I'll be simply getting 1, 2, 3. There is no doubt in this that I would not be getting this thing, right? So print b. Coming to the next line. I want to check out the shape, let's say. That I would just not apply here because you know that the shape will be 3 comma because it is a 1D array. I would be applying now my swapaxes. I will be writing print np dot swapaxes into the bracket b comma 1 comma 0. Firstly, let's say I just apply to 1 comma 0 like this. Right? Now have a look that I was having each and everything into the row. Right? I was having all the values in row. Now they have been turned into the column. So my values which I was having in a row that have been converted into the column. So that is because I have interchanged the values. So in this place I have written 1 and in this place I have written 0. Okay, let's move on to the another one more thing. I would be using out my print statement here, print in bracket. I will be writing np dot swap x's in bracket b comma 0 comma 1 I would be adding here. Okay, now if I just run out my program, so just again have a look that I am getting my new array which is 1 comma 2 comma 3, right? So this is basically how the swap x's work. Okay, this is actually how the swap access parameters work. When you want to interchange some rows or some columns, then in that case we just apply the swap access. Okay. Now the question which I had left in the starting of the video, that was, now if the same thing is done by, okay, just once again, same thing is done by the swap access parameter and the transpose, then what is the difference between the swap access and the transpose function? Basically why we just use them differently. So here we are. What's the use of swap axis? It changes the dimension or the axis of an array, right? Check out the difference in the transpose and the swap axis. So for the transpose, in transpose you can arrange all the dimensions. In transpose, basically what you can do, you can arrange all the dimensions which you have in the transpose. Basically, let's say you have an array that is containing 3 dimensions. So you can just transpose that. But in swap axis, you have a restriction that you can only and only rearrange 2 dimensions. Okay, listen to me here and loud, that basically you can, in the swap axis, you can just rearrange only 2 dimensions, but in transpose function you can arrange n number of dimensions whatever you just wish, right? So this is the very difference between the transpose and the swap axis. And this is the reason why they both have different functions, and basically this was the difference between the swap axis and the transpose, right? So I just hope I made this difference very clear to you, and I even made this thing very clear to you regarding the swap axis, that what's the use of swap axis, how we just apply that in the concepts of the numpy arrays, and how we just do the swap. Actually, now today we are going to discuss about another function in the numpy library, and that is actually a concatenate function. Now, what's the meaning of the concatenate? First, let me explain you that. So, concatenate means to join something. When you just want to join something, so that is actually called as concatenation, right? So, this concatenate function actually what it does, it helps us to join different arrays which you have in your program. Okay. So, this is the use of the concatenate function. Let's say, let me take an example here. Let's say you are having a variable that is a, okay, and in that you have stored an array. You are having another variable that is b. You have stored another array in that. Now you want to join both of these array and make it a single array, right? Then in that case, basically this concatenate function is used, right? Now how to just use out that function, that I would let you know right here. So, as it is a function which comes under the numpy library, so the very first step is to import my numpy library. So, I'm writing here import numpy as np. Okay. Next thing, I would be taking a variable. Okay, I'll be taking a variable. Now, basically, this concatenate function also do not has any particularly thing to do with the help. Okay, inside this help, if you're just going to use it, so it will result you error. That is why I'm just not going to use this concatenate function with the help. Okay, okay. So a is equal to, now what I'll be just doing is here is that I'll be using my arange function. So np dot arange, right? And into the bracket I'll be putting out some range. Let's say 5 comma 1 comma 6. Okay, this is my range which I just entered here. Other than that, let's say I am having another variable which is b. Okay, in that variable itself I would be writing np dot arange, and in that basically I'll be adding here as 6. That is my another like 6 is my stopping point, right? That I have done. Now I want to join A and B. So whatever the numbers are being coming into the A and B, I want to join them. First of all, I would just try to print A and I would even try to print B for the ones that after that when they just concatenate with each other, so it's like easy to understand that basically what is actually happening here. So 1, 2, 3, 4, 5 and 0 till 5, right? That is absolutely okay. Now I would be using out my concatenate function. So for that I'll be using out my print statement for the very first. Then I'll be applying NP. Okay, that is the short form which I have given to my NumPy library. So NP, I'll be applying a dot here, NP dot, and then I'll be adding that concatenate. Okay, that is concatenate. Okay, concatenate right here. Okay, and I'll be putting out the brackets, double brackets, and in that I'll be writing A comma B. That is, I want to concatenate A and B, right? And I would just run out my program here. So just have a look that my A and B. Now A and B have actually been joined here. So in A I was having 1, 2, 3, 4, 5. In B I was having 1, 0, 1, 2, 3, 4, 5. Right. So now they both have been joined with each other, and the new array which I have got here is 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. So this is a new array which I am just resulting here. Right. So basically this is how we concatenate, we join the arrays. Let me just comment out this thing and let's take some another examples as well. So right here I would just start up. So A is equal to, let's say I would be now simply be using Arange function only. Okay. So np dot Arange, and let's say in the bracket I just wrote 6. Okay. I would be adding again. Okay. Let's say B is equal to np dot Arange. Okay, just 1 second. That is Arange. Right. In the bracket, let's say I would be adding here as let's say 7. And for the third, I had C is equal to, that is np dot Arange. And into the bracket, let's say I would be adding 5. Let me come down here, right here. So these are the three arrays which I just want to concatenate into each other. So I would simply be printing out the print statement, and into the bracket, I'll be writing np dot concatenate. Okay, np dot concatenate. Into the bracket, I'll be writing A comma B comma C. These are the three variables in which I have stored my arrays which I want to join with each other, right? And I would just run out this thing here. So basically, have a look that I got one array which is basically all of the values which I have entered in the A, B and C variables. They all are joined with each other here, right? You're able to see 0, 1, 2, 3, 4, 5. This is for the first one that I have taken here till 6. So 6 will be excluded, right? Now again this 0 to 6. This is for the B1. That is my till I have taken here till 7. So that will be giving me only and only till 6. 7 will be excluded, right? Now the C1 is 5. So in that case I am just getting 0 till 4. So because 5 will not be included. Right, this is actually how we just concatenate, we just join out the arrays which we are having in this basically which you are just using, right? Let me just comment out this as well. Now let's take another example. Now let's say I will be defining all the arrays on my own. Okay, I will not be taking any particular function. I will be defining my arrays on my own. Let's say I just wrote A is equal to, I would be putting out np dot array, and into the bracket I'll be writing my 1 comma 2. Okay, so I would be taking one another variable, that is B is equal to np dot, and I would be again be using array, and into the bracket I will be applying let's say 9 comma 8, right? And inside my print statement I will be writing print, and that is np dot concatenate. Into the bracket I will be writing the variables which I want to add, which I want to join actually with each other, right? So in that case we are having A and B. And now I'll be just running it out. So as soon as I just run it, I just got the answer, that is 1, 2, 9 and 8. So basically all of the 4 variables which we have made here, all of the 4 have been joined with each other. Right, now the last example for this concatenate function is that I'll be taking the 3 arrays. Okay. So I'll be using A is equal to np dot array. Okay, that is ARRAY, and the bracket inside this I'll be writing, let's say 4 comma 5 comma 6, right? Now B is equal to again np dot array, and into this array I'll be adding, let's say I'll be adding 14, 15, 16. Okay, and that C, I'll be writing C is equal to np dot array, and into the bracket I'll be adding, let's say 24, 25, 26. Okay, instead of this dot, it's comma, and right here also it's comma, right here. So these are the values which I have entered. Now simply I just want to join all of the values which I am having here. So I would simply use out my print statement. Print np dot concatenate. Print np dot concatenate, and double brackets, inside that a comma b comma c. The values which I want to concatenate, that is the values which I want to join. In this case, the values are actually acting as the array, right? Because we are dealing with the arrays for now. So C, A, B and C, all of these three have joined. So A, B, C is giving, A is basically giving me 4, 5, 6. B is giving me 14, 15, 16. And C is giving me 24, 25 and 26. Right? So this is basically how we just use out the concatenate function in the numpy arrays when you just want to join some different arrays. Okay, when you just want to join the arrays, in that case, this concatenate function is especially used, right? So I just hope I made this thing very, very clear to you regarding the how to use the concatenate function and what's the use of the concatenate. Today I'm just going to tell you about the array addition, right? Basically how you could just add two arrays. So first of all, just let me give you an overview that when you were in your school, so at that time basically we were having a topic that was matrix and determinants, right? So in that matrices, what we have studied about the addition of two matrices, right? In that basically we were given some like n cross n matrices, and we just used to add that, right? That was called as matrix addition. So that same concept actually follows in the array addition also. Simply we just need to declare two arrays of n cross n, basically whatever dimensions you just want to give, we basically declare it like that, and after that we just do the addition. Let me just go on to the one note for now, and just let me explain you that how actually these things works, how actually the addition is done, and after that I'll be telling you on the code that basically how to write out the code for these things, right? So let's say I have an array, and that array is actually, let's say I'm having, it's 1, 2, 3 and 4. Okay, let's say this is one of the arrays which I am having, and I'm having another array that is, let's say 21, 22, 23 and 24. Okay, let's say these are two cross 2 arrays which I am having here, right? You can just call them as matrix as well, right? Because they look like a matrix. So I'm having two cross 2 arrays, and what I just need to do is that I need to do the addition between them. So the procedure which actually follows for the addition is that the first element, okay, the first element of the first array will be added to the first element of the first element of the second array, right? So okay, let me just take out some highlighter here. So okay, let me take this color as well, leave that. So this one, okay, so just 1 second, give me 1 minute time. And from here, this one, the one which we are having here, this element, this will be added with the 21. So like these, the elements are actually added. 1 will be added with 21, 2 will be added with the 22, 3 will be added with 23, and 4 will be added with 24, right? This is a way actually which is followed for the addition of these arrays, right? So when I just come out to the final output, the answer will I be getting is that 21 plus 1, that is basically 22. Then 22 plus 2 is 24. 23 plus 3 is basically 26, and 24 plus 4 is basically 28. So this will be the final addition of both of the arrays that I would be getting, right? So basically this is the procedure, this is the formula which we apply for the addition of two arrays, right? So now I'll be moving towards the PyCharm ID, and here basically I'll be writing out the program for the addition of two arrays, and basically we'll be doing out the code here, right? So let me just get started here. So as these things, I'm just gonna do it with the help of array. So in that case, basically what I'll be needing is that I'll be needing out my Numpy library, because Numpy is the library with the help of which library I'm just gonna make the array, right? So in that case, I'm just gonna write here import Numpy as np, right? So Numpy is my library that I'm writing, and other than that, np is a short form. Now basically I do not have any predefined defined function which I'll be using. So in that case basically I would not be taking the help function, right? because I do not have any name for the particular function that is held for the addition. No, only we just like apply the two arrays and just do the addition, right? So I will not be using that help function for now. Let me just take a variable. Let's say that variable is a. Okay, a is one of the variables which I have taken, and I want to declare an array. So I'll be writing np dot array. Okay, I'll be putting the brackets, and inside this I'll be declaring a 2D array. That is basically the same array which I have shown you on the OneNote, so that we can just tell you the result also, and you just do not get confused a lot. Okay, I'll be taking 1 comma 2 comma 3 comma 4. So this is a 2 cross 2 array which I am taking here, right? That I have done. Other than that, I'll be taking another variable. Let's say that variable is b. Okay, I'll be taking out that. So b is equal to np dot array. So np is basically the name for my numpy library which I have taken, and array is the function which I am using, right? So inside this I'll be writing 21 comma 22. I'll be writing comma, and here I'll be giving the values as 23 comma 24. So let's say these are the two-dimensional two arrays which I have taken. First one is the 1 2 3 4, and another one is the 21 22 23 and 24, right? Now I just want to just do the addition for both of these, right? I just want to apply the addition in that. So what I can just do here is that, okay, first of all, let me just quickly print out A and B as well. Okay, print A and print B, and let me just quickly run out this program for now. So basically here we'll be getting both of the arrays, that is 1 2 3 and 4, and that is 21 22 23 and 24. Just have a look that both of the arrays are here. Right, now I just want to apply the addition on them. So what I can just do is that at the print statement, okay, at the place of my print statement, I could simply write print, okay, and then I can just write a plus b like this, and this will basically give me the addition of a and b, both of the arrays, right? Now let me run it once again, and now just have a look that basically I'll be getting the addition of my array, that is 21, 24, 26 and 28, right? And this was the same which we had seen on the OneNote, right? So basically here 21 is being added with 1, 22 is being added with 2, 23 is added with 3 and 24 is added with 4. So basically the resulting final array after the addition of both of these arrays are 22, 24, 26 and 28, right? So this is the way how we just apply this matrix addition. Other than that, let me quickly comment out all of these things, and let me even take another example also, so as to show you some more things. Right, come on to the next line. Now let's say I just took one dimensional array. Here I have taken 2D array, right? Because it was very simple to see upon this. Now if it is, let's say I just want to take one dimension array. So in that case what I will be doing, I will be taking a is equal to, that would be np dot array. Okay, I'll be putting out the brackets, and one large bracket I'll be putting the value 1 comma 2 comma 3 comma 4. Okay, other than that I'll be taking b is equal to np dot array, and I'll be writing here, let's say 4 till 4 is done, 5 comma 6 comma 7 comma 8, right? These are the values which I have taken as for my one dimension array, right? I would simply print out A as well as I will simply print out the B. So that is okay. That's absolutely fine. You all know that basically how to do that thing. So I just got out my both of the arrays, that is 1, 2, 3, 4 and 5, 6, 7, 8 here, and these are the one dimensional array. Now when I just want to add both of these, so in that case I'll be simply writing print A plus B, right? And I would be running out this program. So basically here I'll be getting the addition of both of these arrays. So just have a look that 5 plus 5 addition with 1 is 6, 6 plus 2 is 8, 7 plus 3 is 10 and 8 plus 4 is 12, right? So the addition which we have taken, it comes on like this, that basically I'm just getting this final 1D array which I have taken here, right? So you want to do addition on 1D, you want to do addition on 2D, you can just apply addition on any of the types of multidimensional array, whichever you just want, right? Here we had seen the example for the 1D as well as for the 2D arrays, right? So let me give you an overview that basically what we had done. So we had actually taken two arrays. Firstly, we have taken two-dimensional arrays, and we had simply it added both of these arrays, right? So A plus B in that case. After that, what I had done, after that, I had taken 1D array and then I have applied the addition of the 1D arrays as well, right? So I hope I just made this thing very clear to you that how you can do the matrix addition for the 1D arrays as well as for the 2D arrays, and basically how the whole mathematical thing, how the whole functioning which is behind this matrix addition, how does it actually works. Right, video we had seen that how you can just do the array addition, right? How you can just add two arrays, how you can add two matrices as well, because we can just call them as matrix because nothing differentiates them from being set as a matrix, right? So we can just call them as a matrix as well. So how you can just do the matrix addition now. Basically, we had another one very important like operation which we just perform on the matrices as well as on the arrays, and that is basically the multiplication. So now basically today we are going to see that how you can just do the array multiplication, or you can just call it as matrix multiplication, right? So I'll be firstly going on to my OneNote, and here I'll be explaining you a little bit about the mathematical things, that what mathematics actually comes behind doing out the multiplication of two matrices. Okay, I was just telling you that thing. So let me just take it out. Okay, just let me quickly do one more another thing. Let me remove it right here. I'll be taking, let's say, 1 2 3 4. This is my one let's say array or matrix, whatever you just want to say. We have taken it, right? And I would just want to multiply it with, let's say, 5 6 7 8. Okay, so just please pay attention that how this matrix multiplication actually works. Please have a look over that. Okay, right here I'll be putting on the brackets. So the first element which we are having 1, the very first element of my first array will be multiplied with this element. So 5 will be multiplied with 1. So it is 5 multiplication 1. Addition sign will be put in between. Now this element, okay, this element, that is my 7 of my column. Okay, this is my one of the columns, right? This column will be multiplied with this number of my row of the first one. So I'll be writing here 7 multiplied by 2, right? Now what will happen, this 6, the 6th number which I am having here, this 6 will again be multiplied with 1. So I'll be writing here 6 multiplied by 1. And this 8, the number which I'm having here, this 8 will be multiplied with the 2. So in that case, I'll be writing plus 8 multiplication 2, right? So for the upper half, this thing actually works. One second. So for the upper half, this thing actually works, right? I'm just removing all of these things right here. Now let me just take again that color. Let me just move out with the things for now. Okay. Now what I would just want to do is that I just want to write out the down thing. So for what I'll do with this 5, the number that is 5 which I'm having, it will be multiplied by 3. So 5 multiplied by 3. Now the 7 will be multiplied with the 4, which number I am having, plus 7 multiplied by 4. After that, the 6 will be multiplied with the 3 as well again. Okay, so in that case 6 multiplied by 3, and this 8, the number which I am having 8, it will be multiplied with the 4. So I'll be writing 8 multiplied by 4, right? And I would just do the operation. I would just apply all the things here and you'll be getting the final output. So I'll be getting 5 multiplied by 1 is 5, plus 7 2 is 14, 6 multiplied by 1 is 6, plus 8 2 is 16. Okay, just instead of 12, that is 16, right? So 5 multiplied by 3 is 15, plus 7 multiplied by 4 is 28, and here I am having 18 plus 32, right? And when you just do out the addition, so 14 plus 5 is 19, 16 plus 6 is basically 22. After that I have 28, it's 38, then 39, 40, 41, 42, 43, it's 43, and 32, then 42, and here I have the 50, right? So this is the final multiplication that will be coming out for these numbers which we have taken, and that are 1, 2, 3, 4, 5, 6, 7, 8, right? This is the final multiplication that will be coming. Let me just quickly put on the highlighter to all of these numbers which we are getting as an answer, as a multiplication of the above two numbers, right? Fine. Now what I'll be just doing is that I'll be moving on to the PyCharm IDE, and here I'll be telling you that how you can just write the code, how you can just write out the program for the matrix multiplication, and how we can just move on with the things, right? So the very first thing that it comes on the topic of the numpy, so I'll be importing my numpy library. So import, and that would be import numpy as np, right? So I've just imported out my numpy library here. After this, okay, actually we have instead of using multiplication sign, we also have one function that is dot. Okay, that dot function is actually used for doing the multiplication only, right? So I'll be first of all letting you know how you can just okay, first I will be telling you how you can just do it with the multiplication sign. After that I'll be telling you how you can just use that function which is dot. Okay, so I'll be taking the variable that is a. So a is equal to np dot array. A is equal to np dot array. We're putting the brackets, large brackets. Inside that it's 1 comma 2 and okay, 1 comma 2 comma and it's 3 comma 4, right? So 1 2 3 4. So 1 2 3 and 4, these are the two dimension array which I have just defined here. Okay, let's say my second variable is b. B is equal to np dot array. Okay, I'll be putting on the brackets here and double bracket I'll be adding here 5 comma 6. I'll be writing comma and then I'll be writing 7 comma 8, right? These are the numbers which are even here. So first of all, what I have just done till now, I have defined my two-dimensional arrays till now. Okay, that is absolutely okay. Come on to the next line and simply I'll be writing out my print statement and putting on the a multiplication b. So basically this will be resulting me the multiplication of these two-dimensional arrays which I am having here. Let me quickly run that out. So just have a look that basically what multiplication I am getting. I am getting 5, 12, 21 and 32. Now let's do one thing here. Okay, so that is giving me 5, 12, 21 and 32. Okay, so this is not that exact answer. Now just have a look. This is not the answer which we have calculated actually, right? We have it. This is not the answer which we have calculated. Now, why I am getting it like this? Because this is not my correct multiplication of the matrix. What it is actually doing is that it is simply multiplying the elements. It is simply multiplying 5 with 1, 2 with 6, 7 with 3 and 8 with 4, and it is basically resulting me the answer. So this is not the correct matrix multiplication which we have, right? So basically what I'll be just doing is that I would be using out my function that I had just mentioned, which is my dot function, that will be giving me the correct answer. So first of all I'll be using out my help and inside that I'll be writing np dot dot like this. Okay, and I'll be running out my program here. Fine, so basically let me just go above and okay, let me first of all take this above here and let me just show you this thing right here. So basically it is telling me that it has three parameters, a, b and out. Okay, these are the three parameters which we have, and basically what it gives us the dot product of two arrays specifically, right? These are the things which we just get it from here. After that, these are things which you can just have a look on your own, and parameters are a, b and out. So a is the array like that is your first array, b is your second array, and output is basically that is optional one. Okay, and what does it returns? It returns us the product of a and b, and basically it will return you an ND array, right? This is the thing which we have here for the this dot function. Other than this, whatever was written, you can just have a look on that only, right? On yourself. Fine. So this a and b is done. Now what I'll be doing is that I'll be using out my print statement, and with that print statement I'll be using that dot function. So first of all you need to write the function on which first of all you need to write the variable name. Let's say I just wrote a, right? A dot. I just put a dot, and after that I even wrote the dot, and in the bracket I just wrote b. So it is basically referring that a dot b. Okay, and now I'll be running out my program here. So now just have a look at what output I am getting here. So I am getting 19, 22, 43 and 50. Go on to the one note here. Now just verify 19, 22, 43 and 50. This was the same answer which we have even calculated, right? So now this is the correct multiplication of two matrices or two arrays, whatever you just want to say it. So it is the correct multiplication of these two, right? Let me comment out this line as well. And let me show you one more example for doing out the same thing, right? Let me show you one more. So let's say I took c as an another variable. C is equal to, and into that I'll be writing np dot array. Okay, I'll be putting out the bracket, and here I'll be writing, let's say I just wrote 9 comma 8, and other than that I will be putting 1 comma and I just write 7 comma 6, right? These are the things which I just wrote. Now, I'll be taking D is equal to NP dot array. Okay, I'll be putting out the brackets and then double brackets here. 9876 is done, and then 5 comma 4, and after that comma, and it's 3 comma 2. Right, this is the thing which I have written here. So after this, I can just simply print, use my print statement, print C dot, and I will just putting the dot as well. I will put the dot, and even I will just write that, right? And in the bracket, it is D, right? I just wrote that thing, and it basically come. And now I'll be running out my program, so I'll be getting out the multiplication of those two arrays which we have declared, and that is basically 69, 52, 53, and 40. Right? You can just like tell it that on your own. You can just do the multiplication of both of these arrays which you have declared, and after that you can just have a look of that, right? So basically, I hope that it must be very much clear to you that how you can do the matrix multiplication, and if you apply the A multiplication B, so in that case what result you will be getting, and if you just apply the dot function, then in that case basically what output you will be getting. So by applying this dot function, you will be getting the very accurate and the very correct answer, right? So I hope I just made this thing very clear to you how to apply this multiplication with the arrays, right? So basically we are just dealing out with some mathematical things till now, right? We are just seeing that we had seen about the addition, we had seen about the multiplication, and now basically today we are going to see about one more another topic, and that is basically the linear algebra. You all know about the linear algebra, right? So basically how you can just use that linear algebra to inverse the matrix, right? Today we are just going to use that thing. So actually linear algebra, that is Linalg. It is the name of a function actually. That is why I'm just pronunciating as linear algebra. Other than that, it has nothing to do with actually the linear algebra, okay? It basically we just work upon the arrays only, right? So basically I'll be letting you know that how you can just inverse a matrix and all that things, how you can just apply all those things, right? So the very first thing that goes here is that I need to import my Numpy library, import Numpy as NP. Now basically in the very starting only, I just told you regarding the Numpy library that it is a type of library that actually has that is actually useful for doing out the mathematical calculations, right? I just mentioned this thing in the very starting of this course. So that is why I am just making you familiar with all of the mathematical functions which we have in the Numpy library, so as you can just have a good knowledge of that. You can just apply these functions now anywhere, wherever you just write your code. If you just do some data science stuff, so you can just basically apply these functions onto that and come to a better and a good output, right? So that is why I'm just letting you know about all of these things. So very first thing, inside my head function, I'll be writing np dot, that is linalg. This is the name of the function we have, okay? I will put a dot and just write, I will be writing here inverse. So that is linear algebra inverse actually, okay? And I will be running it out here. So basically I just got to know a little, like many things regarding this thing. So let's have a look at what we are getting. So inverse A, it basically computes the multiplicative inverse of a matrix. It basically tells us the multiplicative inverse of a matrix, right? And this is only the formula and the syntax which is applied. You just need to write the inverse, and in the bracket you need to write the name of the variable in which you just want to apply your inverse function, right? This is the thing that actually goes on. Now, as I mentioned that this is the only parameter which has A and matrix to be inverted. It says you need to write out the variable name in which you have stored your matrix which you want to be converted into the inverse format, right? That I have done. Now what it actually returns? It actually returns an empty array or matrix, and it inverses the matrix, right? Whatever like matrix you have taken, it will actually inverse that matrix. So other than that, these are the examples and all the things which comes under this linalg dot inverse function. So you can just have a look of these things on your own afterwards, like, okay? Now I will be taking a variable. Let's say that variable is A, and I'll be taking it for declaring an array, right? So A is equal to, I'll be using here np dot array. np dot array is the name of my I'm just trying to declare an array here. I'll be putting out the bracket here, and I'll be declaring a two-dimensional array. Let's say my array is 1, 2 and 3, 4. So here, by the time you all must be familiar that when I'm declaring a 2D array, when I'm declaring a 1D array, when I'm just declaring a 3D array, right? You must be familiar with all of these things till now, right? So as seeing the code only, you must be able to guess this thing right here, that basically which array actually I am declaring here. So for this example, I am declaring a 2D array, right? I just want to print that out. So I'm writing print, and in the bracket I'll be adding here as A. Let me now just run it here. So this will be coming it out like this, 1, 2, 3, 4. This is actually how my array 2D array looks, which I have just declared here, right? It actually looks like this. Now, I want to apply that linear algebra inverse function, which we have, which I just mentioned that we'll be seeing out this function. I just need to apply that. So for that, I can just take another variable actually, because I do not want my real array to be disturbed, right? I do not want that it should affect my real array. So as to like restrict that thing, I'm just taking another variable, and into that I'll be applying that inverse function and doing the inverse of my variable, that is A, and in which I have stored my 2D array, which I have declared, and that is 1, 2, 3, and 4, right? So basically, I'll be writing here np.linalg, np.linear algebra dot inv, that is inverse, right? And I'll be putting out the brackets and writing out the name of the variable which I want to inverse here. That is A for me, right? And now I'll be simply printing out the B, the variable in which I have stored my inverse of my A matrix. So just have a look here, that previously I was getting 1, 2, 3, and 4, and after the inverse I'm just getting minus 2, 1, 1.5, and minus 0.5. Now this inverse actually has its own other formulas, its own other techniques to do. So basically I'm not going to discuss that thing, that how this actually inverse works onto the like mathematics and all those things, because like we are just discussing about the functions right now here, right? So from this basically you can just get to know that basically this is how the inverse function actually works. Okay, this is how we like this inverse function actually works. We just apply this inverse function onto the other things, and we just get the like inverse of that particular like number which we are and the like array which we are wanting, right? Let's take another example. Let's say I just took here C is equal to, and that would be np dot array. Okay, now let's say I just take a one dimensional array. Instead of 2, I'll be taking 1D array. Okay, I'll be putting out one bracket here, and let's say my array is 5, 6, 7, 8, right? Let's say this is the array which I have declared, and it is my one dimension array, right? That is thing all you all know. So I'll be simply printing out this array, that is C. That is absolutely right here. Now I'll be taking one another variable, that is D. Let's say that is D. Now that totally depends on you, that basically what type of variable you are taking, how much meaningful variable you are taking, how much non-meaningful variable you are taking. That all of these things actually depends on you only, right? So, so basically D is equal to, and I'll be writing here np dot, and that would be linalg. This linalg is actually referring to the linear algebra. Okay, and dot inv. This dot inv is actually the inverse. So inside the bracket, I'll be writing the name for the variable on which I want to apply out this variable function, so this inverse function. So that is C for me, right? And inside the print statement, I'll be writing here as D. And now I'll be running it out. So, okay, one dimensional array, given array must be at least 2 dimensional. Okay, fine. Basically, you just saw that when I just tried to run this linear algebra function on 1D array, so it gave me error that numpy.linear algebra error. One dimensional array given array must be at least 2 dimensional. So this means that actually you cannot apply this linear algebra function on one dimensional array, right? You cannot just do that thing. So if you just want to apply the inverse function, so you need to take that 2D arrays as well, because in the inverse function, rows and columns are actually both are needed, like with the same thing, both of them are needed, and the final output which you will be getting at the inverses, it is calculated with the help of the rows and the columns as well, right? So because of that only it is showing me that 1D array is not allowed, because in 1D array we only have one dimension, that is row, right? We do not have any particular columns here, right? So I hope I just made this thing linear algebra dot inverse function very clear to you, that how we just apply it, what are the functions which we just do on this, and how we just write out this function in the NumPy arrays. So basically today we are going to discuss that if we just want to find out the power of an array or power of matrix, whatever we just say, that how we will be doing that thing. So basically now we'll be seeing one function that is okay, I'll be telling that function in the little bit time, but for now let me just tell you that what we are just going to find. So we are going to find the power of a matrix. If I just say that matrix or if I just say that array, both terms are actually same, right? Because there is no such difference between both of the declarations of these. So I can just say anything, whatever I just like want to, right? So firstly what I'll be doing is that I'll be checking out that how I can just find out the power of a matrix. So for that I'll be importing out my NumPy library for the very first. Import NumPy as NP. So I'm just importing my NumPy library as NP, that is basically I'm just giving it a short form, right? Now what I can just do here is that I can take a variable that is, let's say, A. Okay, A is equal to, and I could apply np dot array. Okay, A is equal to np dot array, and let's say I declare a two-dimension array, and that is, let's say, 3 comma 4 comma 5 comma 6, right? Let's say this is a two-dimension array which I have declared here. Now I want to print this array, so that is super easy for me, and we are just doing this thing from the very starting. I just simply take the print statement, and inside that print statement I would write the name, and that is A, right? And sorry, the name of the variable, that is A, and here it is done, right? Now I'll be taking one another variable that's, let's say, that is B. Okay, I'll be taking out that. So I'll be writing here np dot linear algebra. So this function actually comes in the linear algebra only, that is LINALG. It comes under this thing only, so I need to use out this here as well. Okay, so B is equal to np dot LINALG. I'll be putting out the dot here, and I'll be writing here matrix. Okay, I'll be writing here matrix underscore power. So I just mentioned that we are going to check out the we're just going to find like compute the power, right? We're just going to compute the power of a matrix. So in that, the function name which we are going to use is matrix underscore power, right? I'll be putting out the bracket. Inside that, I'll be writing out a name for the variable in which I have stored my array, for which I want to compute out the power, right? A comma, and let's say my power is -2, right? And I would simply print out my B, the variable in which I have stored my array, right? Matrix, whatever you just call it. So basically here just have a look that first my array was 3, 4, 5 and 6. Now after finding out the giving out a power of a matrix, then what I'm just getting as an answer? So I'm getting as an answer that is 14 minus 9 minus 11 and 7. So it's not the thing that whatever the elements you are having, what are the elements you are having here, that is 3, 4, 5 and 6. These all will be getting squared and you'll be getting the answer. No, it's not like this. The power is computed with another procedure, that is totally another way, that how we just compute out the power of a matrix, right? So this is not the thing that actually that each and every number will be squared and we'll be getting out the power, we'll be getting out the new matrix that will be containing the power too. No, this is not the thing, right? So basically what we need to do is that we need to take out the matrix underscore power function, and in that basically we need to write out the name of the like variable on which we want to perform out the power function, right? And what power you just want to give it to. Let's say that is, for me, I'm just giving it as -2. So in that case, basically it is resulting me the new array which I'm just storing in the variable which is B, and I'm simply printing out that variable that is B, right? So this is the whole procedure that we actually follow for the power of a matrix, right? So this was another function which we have and which we apply on the arrays, and you can just call it as matrix as well, whatever you just wish, right? So I hope I just made this thing very clear to you, that how you can just apply this function, how you can use this function, and how you can just check out the results for that. Say that basically how you can find out the determinant of an array. If you are given an array and you just need to find out the determinant, so how you can just find out using a Python program, right? So in the NumPy library, under that linear algebra function, we have another function that is called det, that is actually referring to my determinant. So if you just want to find out that determinant, so we just simply use the det function, and it basically gives us the determinant of the number of the, sorry, of not a number, of the array of a matrix which we are actually planning to find out, right? This is the whole idea regarding this determinant function. So let's see the program, let's see the code, that how to use out this function, what are the parameters that you can apply, what are the things that you can see here, right? So as this function comes under the determinant one, so I would be writing here the import, and I would be importing my Numpy library. So this determinant function actually comes under Numpy library, right? So I'm just using that right here. So import numpy as np. Now here I can just use out my help. I can just write help, and in the bracket I'll be writing np dot linear algebra. That is LINALG is referring to my linear algebra dot, and that is det. That is my determinant. And now I would be running out my program here. So basically, as soon as I just run it, just have a look that what are the things that I'm just getting here. So it is telling me that the parameter is a, and okay, here it is the function determinant a. So only takes one parameter, which is a. Other than that, it does not take any parameters, right? So a is basically the array which you want to find out a determinant of, and what it returns a determinant of a, right? Other than that, basically, see, here are some more things which you can just look on your own. So I'm just not going to tell you that thing right now. You can just have a look over that on your own, right? I would just comment this line, and let's see that how this function actually works. So let me take an variable and define an array here. So a is equal to np dot array. That is ARRAY. Okay, I'll be putting out the bracket here and giving a 2-dimension array. So my 2-dimension array goes here like this, 3, 4, let's say, and I'll be giving you 1, 2. Right? Let's say these are the values. And I simply want to print that out. So print, and in the bracket it is a, right? So it's just basically the way how we just print out a statement, right? Sorry, print out an array. 3, 4, 1, 2, this is my array. Now, let's say if I just want to find out the determinant of this, so I can just use it and take another variable. In that, I can just write np dot, and basically I can just write np dot linear algebra dot det. That is basically for finding my determinant, and I can just write the name of the variable for which I want to find out the determinant. So that for me is a, and I would simply print out the b. And now let me quickly run out this thing here. So basically it is giving me that the determinant for your 2 cross 2 matrix which you have taken 3, 4, 1 and 2, it is 2 points somewhat up to n number of zeros and then 4. Now basically let's say I just want to round off this value. Okay, I just want to round off this value and get an actually accurate round off value. So in that case I can take a new variable, that is, let's say c. Okay, c is equal to, I can just write here round. Okay, basically that will round off my n digit value, that is I'm just getting after that point. Okay, so round, and it is np dot linalg, that is my linear algebra dot det, that is referring to my determinant, and here basically I'll be writing the variable for which I want to round it off. So that is a basically, right? And I would just simply print out the c here. It's not, yeah, it's a. And now just let me quickly run that here. So now just have a look that basically now I'm just getting a rounded off value, that is 2. Okay, now this point 000 up to something 4, it's not basic, we do not need it, we just needed a rounded off value, so we are just getting a single integer, and that is 2. So 2 is basically the determinant for all of this 2 cross 2 matrix which we have taken 3, 4, 1 and 2, right? So we had seen an example for this one. Let's move and see an example for another array. Let me take a 3 cross 3, 1. Let me write here here is equal to np dot array. Okay, I just put the bracket and double brackets here, and let's say my array goes like 5, 4, 3. I would put one again, comma. Then I would write 6, 5, 4. I would again put one comma, and here I'll be writing, let's say 3, 2, 1. Okay, let's say these are the values which I just need to put on here. Right? I would just do enter, and I would simply start printing the a. So print and then a. Right, and I would just run it out here. So as soon as I run it out, it will basically give me the array which I have just mentioned here, which is of 3 cross 3. Right, that is absolutely fine. Now what I just need to do is that I need to take another variable which is b. Okay, so b is equal to, and that would be np dot linear algebra, that is linalg dot, that is dot determinant, that is det and then a. Right, and I would just simply print out, okay, I would just use here print and then b, right, and I would just simply try to run out my program. So it is giving me somewhat 2.66 and like up to many places. Now if I just try to round off this value, if I just write c is equal to, and I just use here, okay, that is round dot round, and in the bracket I just write np dot linear algebra dot det, and in the bracket I just write a, and this here I just print out the, see, I just want to find out a rounded off value. So I will just run it here and just have a look. Okay, basically what it is giving, which is giving me, okay, that is round np dot linear algebra dot det, right? So basically does not gives the accurate answer for the three ones. Okay, it only gives for the two, right? So basically this is how which you can just use your determinant function of the numpy library to find out the determinants, to find out a determinant of any particular matrix or array which you are getting, right? And you can just round off that value as well, whichever you are just getting, right? So I hope I just made this thing very clear to you, that how you can just use out this determinant function and how you can just use that in finding out the determinant of a matrix or an array, right? So this is all for this video. Till then, thank you and take care.